the global shift towards ethical, innovative, and technologically advanced methods in biomedical sciences. And I hope this event will provide a meaningful platform for learning, collaborations, and scientific progress. I invite dignitaries on the dais, our chief guest of the occasion, Professor Dulal Panda, Director, National Institute of Pharmaceutical Education and Research, Dr. B. Kalakumar, General Secretary, Indian Pharmacological Society, and I request Professor Anil Kumar and Professor Kamalji Chopra, Organizing Chair IPSCON 2025, to please escort. We are honored to have amongst us Professor Dulal Panda, Director, National Institute of Pharmaceutical Education and Research, Mohali, who has graciously agreed to inaugurate this pre-conference workshop. We warmly welcome you, sir. I request to extend a floral welcome to Professor Dulal Panda. We have amongst us another very important figure in the field of pharmacology and veterinary science, best known for his role as the General Secretary, Indian Pharmacological Society, Dr. B. Kalakumar. We welcome you, sir. I also welcome Professor Kamalji Chopra, Professor of Pharmacology, UIPS, and Organizing Chair IPSCON 2025. Professor Anil Kumar, Chairperson UIPS and Organizing Secretary IPSCON 2025. Dignitaries of the dais, esteemed faculty colleagues, invited speakers, delegates, and dear students. As we begin, let us invoke the blessings of Ma Saraswati for wisdom and proceed to the ceremonial lighting of the lamp, a symbol of knowledge, enlightenment, and the victory of truth over darkness. I invite all the dignitaries on the dais to kindly proceed for the lamp lighting. Udhar se Now, I invite Professor Anil Kumar, Organizing Secretary IPSCON 2025, to welcome the gathering.
Thank you, Dr. Sangeeta. Very good morning to all of you. It's my great honor to welcome you all in the inauguration of pre-conference workshop centered on the theme Emerging Tools and Technologies, Alternatives to the Animal Testing of 55th Annual Conference of Indian Pharmacological Society, hosted by UIPS Punjab University, Chandigarh. This year, the workshop and conference are centered around the theme of exceptional contemporary relevance, emerging tools and technology, alternatives to the animal testing. Contemplating to this is a central conference theme of IPSCON 2025, namely empowering young minds to transform pharmacology for Viksit Bharat. Together, these themes reflect an aspirational and forward-looking scientific agenda that emphasizes ethical innovation, technological advancement, capacity building, and renewed commitment to shaping India's pharmacological progress by 2047. At the outset, it is my privilege to extend respectful, heartfelt welcome to our chief guest, Dulal Pandaji, Director, NIPER, Mohali, whose distinguished presence lends a great significance to this inaugural session. I also extend a warm welcome to our guest of honor, Dr. P. Kalakumar, General Secretary of Indian Pharmacological Society, whose leadership and vision continue to guide National Pharmacology Initiative. I further convey my sincere greetings to all resource persons, academicians, scientists, delegates, research scholars, students joining us from across the country. Your presence enriched the academic depth, collaboration, spirit that define the Indian Pharmacological Society. Before I move to the details of the session, it is very important to know that this event contained till now more than 900 registration and 234 international speakers, including national speakers. So it is a big gathering of next 3 days, Just to summarize this one. Now comes to the pre-conference workshop that has been diligently designed to provide a comprehensive scientific orientation towards non-animal, human and technological advancement experimental system. Over 2 days, participants will engage with integrated platforms of in vivo alternatives, in vitro innovations, in silico intelligence, reflecting the global shift towards reproducible, ethical, high throughput and mechanism-informed pharmacology. The scientific program will begin on session 1 on zebrafish as a model organism, featuring the eminent experts who will elucidate multifaceted utility of zebrafish in neurobehavioral studies, regeneration biology, nanotoxicology, metabolic disorders, high content data generation, and this will be complemented by hands-on demonstration in zebrafish husbandry, live imaging, behavioral assay, and advanced microscopy skills that are increasingly indispensable in modern biomedical research. Session 2 will highlight the cell-based model system, including organoids, advanced cell culture methodologies, genotoxicity testing, human drugs will be delivered by distinguished scientists, development biology, toxicology, and translation pharmacology. Similarly, on day 2, there is a parallel session on computational approach that will expand scientific horizon by integrating network pharmacology, chemoinformatics, docking simulations, in silico ADME predictions, and generative AI framework approaches that now from the background of drug discovery, mechanism-based research, ethical alternatives to the preclinical testing, and collectively the workshop as unique scientific bridge connecting web lab innovation with the digital pharmacology. These pre-conference workshops set the stage of 3 days scientific deliberation of IPSCON 2025, commencing on 20th November, which promise to be intellectually enriching, globally aligned workshop. This conference will open with a theme address on empowering young minds to transform pharmacology for Viksit Bharat, and a distinguished plenary lecture by Dr. Naranjan S. Dhalla, distinguished polyclonal antibodies mediated cardioprotection in ischemia reperfusion injury. Over the subsequent days, IPSCON 2025 will host a remarkable scientific program comprising multiple prestigious orations, 25 specialized symposia, invited lectures, oral poster sessions, women forum, panel discussion with industries, spirited IPSCON quiz. The theme span critically area including translation neuropharmacology, molecular core technology, clinical innovations, emerging metabolic, cardiovascular therapeutics, biologicals, biosimilars, herbal, nutraceutical sciences, regulatory frameworks, and list is long. Importantly, this year, conference strongly aligned with the national vision of Viksit Bharat 2047 and emphasizing not only scientific excellence but also ethical responsibility, innovation-driven healthcare, young researcher empowerment, multispectral collaboration including academia, industry, regulatory bodies, and global partners. by foregrounding alternatives to the animal testing and emerging experimental technology. IPSCON 2025 underscores India's commitment to responsible science, international harmonization, and future-ready research ecosystem. As we formally commence this pre-conference workshop, I encourage each participant to immerse themselves in the scientific sessions, interact with experts, embrace new methodological perspectives, and build network that will shape your future contribution to pharmacology. I am confident that these 2 days will provide deep insight, hands-on competence, conceptual clarity, meaningful dialogues, serving as inspiring prelude to the dynamic scientific conversation that awaits us as IPSCON 2025. Thank you once again. Extend a warm welcome and sincere welcome to all of you to the IPSCON 2025 pre-conference workshop. May the coming days be intellectually stimulating and scientifically transformative. Thank you.
Thank you so much, sir, for your welcoming words and for providing an overview of the pre-conference workshop and the main conference. Certainly, this mega event will enrich our participants with a bonanza of scientific deliberations, fostering valuable networking opportunities and fruitful collaborations. Dr. B. Kalakumar is amongst us, who currently holds the position of Professor and Head of the Department of Pharmacology at the College of Veterinary Science in Rajendra Nagar, Hyderabad. It is my privilege to introduce a distinguished leader, General Secretary of the Scientific Community, Indian Pharmacological Society, one of the oldest professional bodies in the field of pharmacology in India, committed to promoting excellence in research, education, and therapeutics. And Dr. B. Kalakumar has been instrumental in steering several national initiatives, strengthening collaborative networks, and enhancing the scientific reputation of IPS. With these words, I request Dr. B. Kalakumar, General Secretary IPS, to kindly present an overview of the Indian Pharmacological Society.
Dignitaries on the dais, and I see some familiar faces also. Professor Karnasri from AIMS Kalyan and other people. Thank you very much for being with us today. This is a learning experience. Pre-conference workshop is a learning experience, and basically I am a preclinical pharmacologist. So more than the main conference, I will be interested more in pre-conference because it's my area. It's my area of work, area of interest. And we all know that if we read, we forget. If we write, it will be retained. And if we do, it's going to be there for quite a long period of time. And that's how you gain experience. When you do, you gain experience. And this is what is experiential learning provided by IPS. And the mandate of IPS is to promote the knowledge of pharmacology, both for the cosmopolitan cities and also in the interiors. Recently, we had one workshop in Nasik. It was, not even in Nasik, about 60 kilometers away from Nasik. But the gathering was very, very good, and really that motivated us, and we were encouraged that we should even look at the rural pharmacy colleges and the rural pharmacologists also. Right. And coming to IPS, as introduced, this is an old scientific body, and we have so many other societies being formed. Of course, growth is a parameter that indicates that there is life, and there is life in pharmacology, and so we have many societies. But the uniqueness of IPS is that it's a multidisciplinary society. You have both medical people, the veterinarians, and also the pharmacy people all coming together to share their ideas, to share their knowledge, to share their expertise. And you have ample space for ample opportunity for networking with all the stars that are there in the field of pharmacology, both in the industry as well as the academia. And My slogan everywhere would be IPS provides one for one. If you are a youngster, you would be given a prize. If you are a little bit in the middle age, then you would be given oration. And if you are in the old age like me, and then we will be providing with lifetime achievement award or other awards. So one for everyone. So that's our slogan, and that's how we promote pharmacology. Thank you for giving me this opportunity, and I especially congratulate Dr. Anil, Professor Kanwaljit Chopra and their team for organizing this pre-conference workshop, because the learning takes place here. And in the main conference, we only listen to the lectures, but here you do learn and remember it for your lifetime. Thank you.
Thank you so much, sir, for enlightening the gathering with your nice words. Today, we have the distinct honor to hear a remarkable personality whose insights, experience will enlighten each of us present here. We are privileged to have amongst us Professor Dulal Panda, Director Naipar, Mohali, and it is my proud privilege to introduce him. Professor Dulal Panda is a distinguished Indian cell biologist and current Director of the National Institute of Pharmaceutical Education and Research, Mohali. He earned his PhD in biochemistry from Rose Institute, Kolkata. After completing his postdoctoral research at the University of California, Santa Barbara, he returned to India and joined IIT Bombay. Professor Panda's research focuses on microtubule dynamics, cell division, cancer chemotherapy, and FPSC assembly dynamics in bacteria, with a strong interest in developing FPSC-targeted antibacterial drugs. He has published over 190 papers and holds multiple patents, both American and Indian. He is a recognized scientist with many awards and accolades like National Bioscience Award by BPT, Tata Innovation Fellowship by BPT, the G.N. Ramachandran Gold Medal, Swarna Jayanti Fellowship by DST, and many more to the list. He is a fellow of major Indian academies like Indian Academy of Sciences, Indian National Academy of Sciences, and National Academy of Sciences, India. Professor Panda took over as the Director of NIPA Mohali in July 2021, and under his leadership, NIPA has strengthened its focus on the cutting-edge drug discovery, robust industry-academia partnerships, and innovation-driven research aimed at advancing India's pharmaceutical ecosystem. With these words, I request you, sir, to kindly share your words of wisdom with us.
Good morning, Professor Kalakumar, Professor Kanwaljit Chopra, Professor Anil Kumar, and other colleagues from other universities, distinguished delegates, and my dear students. I think it is a pleasure to be here. I always consider it is a fortune to be present anywhere where there is pharmacology. And I do not have a pharmacology degree, but if this will be wrong to say in a forum, but probably I have published more biochemical pharmacology and molecular pharmacology paper than very few exist in India. Probably that is not correct to say in that way, but so that tells me that I do get into this area. Okay. But my journey came into pharmacology because of the pharmacological tools. It is truly an interdisciplinary subject, very important subject, because if you think of pharmacology today, it is, not today alone, but from a very long time, there is a drug discovery and mechanism. Okay, discovery and mechanism. So it is not attachment with any discipline. It is an amalgamation of so many different kinds of discipline, where you are looking drug discovery and drug mechanism. Now, that's why it is, you need actually expertise from different directions. Today, that I am very happy to see this, the pre-conference subject, alternative to animal model. I will come to this. But today, if pharmacology has to, pharmacology as a discipline has to stay and really fight with the biologists or others, because the biologists are doing much more pharmacology, strong pharmacology paper than traditional pharmacologists are doing. Because the techniques today that is required is not only the small molecule, but in order to understand the mechanism of action of taxol, you need to use molecular biology techniques. You needed to get CRISPR technology, you needed to use antisense, you needed to use molecular biology. You have to have ability to purify proteins, look at the proteins in their pure form, and different, lot of physical techniques. Okay, this is very critical today, that people have understanding of molecular biology techniques and the physical techniques. And I was fortunate that though I did PhD in biochemistry at that point, but it was really biophysics. Again, I have never studied biology formally. I was a chemistry graduate, MSc in chemistry, PhD in biophysics, though it was a biochemistry department, postdoc in cell biology. Started looking at and using molecular techniques along with the small molecule as a tool, and trying to discover the drug candidate for cancer and antibacterial. So I have had 9 patents in India, including 3 American patents for drug discovery, but that is a different issue. But looking at, using different techniques, that's what I wanted to put emphasis on. Understanding today molecular biology techniques and the spectroscopic techniques, structural biology techniques are very critical for everybody. Until and unless you get the molecular techniques, it's difficult. Now, looking at today's pre-conference, that animal alternative to animal model, just think of that nearly 80% cases, animal cannot give you correct either safety or efficacy. Even whatever works on rat, that does not sometimes work on mice. But think about, say, penicillin. Penicillin, a rat or mice is somewhat tolerant. But if you have tried it on guinea pig, it is highly intolerant. Guinea pig cannot tolerate penicillin. Or if you think of paracetamol, the animal cannot tolerate paracetamol, rat or mice or this. As a result, you would never have these drugs. If it was there that time, the animal trial was mandatory that time. So that tells you combination of that, 80% time it cannot get any efficacy, and 80% time even the toxicity is wrong. So you need alternative. There is no two minds about it. But here this is very important to understand that pharmacology or drug mechanism, you never have one single answer for something. So you needed to look at multiple approaches. So today you think geography is a very good model, but is it going to substitute rat or mice? Very difficult to tell. I don't think so. In certain cases, you will get some information. Very good model is organoid also. I have spent all of my life in cell culture. I will say, okay, cell culture is also good model. But alone, any model, including animal model, it's not substitute. So if it is that, I'll tell you, I was a postdoc that time. I was working with a compound. We were very excited because this compound has a very good activity, even rat and guinea pig. But when you put in dog in the Eli Lilly compound, that just get metabolized like this. And so no activity, because as soon as you give it get metabolized and get so there is nothing you can. So what happens in rat may not be reproduced in human. So only way to look at it, if you look at different models, you learn from different models. And in that case, you do not need to use the rat or mice. Every passing day there are more ethical problems are coming. So you can use more organoid models, more geographist model. You can use more cell culture model, and on the top of it, one can start looking at AI to get some coordinate all these models together to get an understanding. So that's why pharmacology requires multidisciplinary training today. I think I came only wanted to tell this, that today pharmacology has a very, very crucial role in shaping this country. Government of India is looking at 2047 to export huge amount of drug and thinking that this will be new, not only the pharmacy of the world, the generic medicine, but new. And that's where the pharmacologist has a role, big role to play. And how do we play this role? Until and unless we have ability to express proteins. Okay. Now, someone, traditional pharmacologist will think that, oh, this is not in that area. But the time if you wanted to look at biologics, if you look at antibody, if you want to look at antisense, then you have to get all these things. So it cannot be in isolation. And small molecule mechanism, if you look at curcumin. Every Indian scientist in India, starting from any university you take, there are hundreds of papers on curcumin, and chemistry, biology, and biologists and pharmacologists found out hundreds of different mechanisms. Okay, how do we really think today? Now today the idea is for curcumin is that it is actually protein active molecule. It interacts with protein because it has a pain structure. But actually in cells, what does it work? That depends on what it is available to it. Which cell line you are using it, what it is available to it, how much it goes. Because it has a protein active molecule. Any protein it will bind. Also, pharmacologists should be very careful in things. For example, in test tube, I will just tell you one story. All of you stain DNA using DAPI. Okay. DAPI also binds to a protein in vitro tubulin. Okay. But in cells it will never. So if someone publishes a paper looking at in vitro binding of DAPI in tubulin, okay, it will work on tubulin. But in cells it never does. Thousands of fluorescence pictures are published, or millions, never. even when I joined in IIT Bombay, I did not have centrifuge to study actually tubulin polymerization and depolymerization. What I did, I actually found out that DAPI binds more strongly to microtubule than tubulin. I used the difference to actually study the polymerization and depolymerization and publish the paper in biochemistry that time, okay, in 2002. So, but it has no physiological consequence. I will end this saying that, so what I want to tell you that looking for different methodology is very critical. That's why when you learn organoids, we are fortunate today in India there are several organizations now have people who are trained in Naikar Mahal. He has 2%, one probably is giving talk in this meeting, but there is also another one who got trained from PGI and Stanford, joined Naikar Mahal. He is also very good guy on organoids, Ajay. And I think someone, Ujjal is giving talk. So that every organization now is having people who have organoid. Similarly in geographies, cell culture model. So let us integrate, understand and do this. I think pharmacology is the subject going to have a very strong future in India, and the future can be materialized only if we truly become multidisciplinary. We get more engineering people in it, so more physics people in it, so that they can actually do the model. Today you can have quality of data. Okay. I will just tell you one more story though. I think when in my early days I was working on single molecule dynamics. There is time very few people used to work in single molecule dynamics, looking at microscopy. But physicists would not model it because they would not think that this is very high quality data. Okay. But today, I think you can generate a lot of very high quality data where the people from physics and chemistry can do the modeling, and that is important. I think it will be, Punjab University is fortunate to have a very strong chemistry department. Similarly, many places here close like that chemistry and physics department. Biologists do modeling, but they cannot excel. I'll tell you, in IIT Bombay, I had 2 physicists to do biology, and their modeling level is completely different compared to the people who are doing modeling but trained in biology. You cannot simply compare them. Okay, their ability is completely not. So you need multidisciplinary approach. Being more physicist, engineer to the subject, get AI. Biologists can keep talking about AI, but we will not get AI without having a strong basic in statistics and mathematics. How many biologists, pharmacologists actually understand mathematics? How many can write differential equations? So you need people to do this. Otherwise, you'll keep talking big, generative AI. कुछ नहीं होगा. और generative AI, in order to do that, you need mathematical person who will help you, who you needed to teach biology. So I hope I did not make too much on this, but the point that I wanted to put, this is the time India has a great expertise in different subjects. Pharmacology is something where minds from different area can come. And my last thing I will tell you, today you look at Indian biologists, and please find out from where they have come. What was their initial discipline? Okay, starting from Jitu Mayer or Professor Balaram or Shekhar Mande or Bilal Panda, whatever you see, what is their background, initial background. You will see there are a lot of multidisciplinary people. Pharmacology also needs that. Okay, and thank you. I think this is a real exceptional attempt, and I'm really bold out just looking at the topic. this kind of topic needed to be really thought very seriously, and so many good speakers, they will talk about this. And I hope you enjoy and learn something and make it much more multidisciplinary in India. That's it.
Thank you so much, sir, for your inspiring address and insights, which will truly inspire and motivate the scientific community sitting here today. Now, it is the time to honor our distinguished guest. I would request Dr. B. Kalakumar, General Secretary IPS, to honor Professor Gulal Panda with a token of respect and gratitude. I request Professor Kawaljeet Chopra and Professor Anil Kumar to please join.
Sangeeta is straight behind, you know.
Now I request Professor Gulal Panda to honor Dr. B. Kalakumar, and sir and ma'am to please join. Thank you so much. As we come to the close of this inaugural ceremony, it is my honor as the Joint Organizing Secretary IPSCON 2025 to extend the vote of thanks. First and foremost, we express heartfelt gratitude to our chief guest of the occasion, Professor Gulal Panda, for taking time from his busy schedule to grace this occasion. Thank you so much, sir. Our sincere appreciation also goes to the General Secretary IPS for the valuable overview and suggestions for successful conduct of IPSCON 2025. We warmly thank all the dignitaries and invited guests for accepting our invitation and honoring us with your presence. We are deeply grateful to our esteemed speakers and resource persons who will be enriching us with their knowledge throughout the workshop. A heartfelt gratitude to the university officials, the organizing committee, faculty colleagues, and the dedicated student volunteers for their unwavering support and meticulous efforts in ensuring a smooth and successful start to this event. Special mention and acknowledgement to funding agencies like DPT, ANLF, NUSA, DSTUT, and industry sponsors for their generous backing. We also thank PETA India for instituting a prestigious award to recognize the researcher working on the methods for replacing animal use in regulatory testing. Their support reflects commitment to advancing pharmacological sciences and has played a vital role in making this pre-conference workshop and IPSCON 2025 event possible. I place on record a special thanks to Professor Kawaljeet Chopra, Organizing Chair IPSCON 2025, whose constant support and vision has been instrumental in shaping both this workshop and the upcoming conference. Special thanks to Professor Anil Kumar, Organizing Secretary. Under his leadership, the organizing team has worked tirelessly to shape a scientifically rich, engaging, and forward-looking program. Finally, a special gratitude to all our participants who have come from different states across the country to truly bring life to this event. Once again, thank you all for your time, support, and participation. We look forward to productive sessions ahead and to meeting you again during the main conference. And I request all of you to please rise for the national anthem.
चञ्चल जलधितरङ्गा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you. Now I invite dignitaries on the dais and all the invited guests, faculty to please join for a cup of tea. And I request all the participants to please be seated because we are going to start with the scientific session. So after after 5 minutes we are going to start the session. Without further delay, let us begin the first technical session. And I invite Dr. Damanpreet Singh, Principal Scientist, CSR Institute of Himalayan Bioresource Technology, Palanpur. Dr. Singh earned an M.Pharm specializing in pharmacology from GNDU, Amritsar, India. He then completed his PhD in pharmacology at Punjabi University, Patiala, and became an assistant professor in the Department of Pharmaceutical Sciences and Drug Research at the same university. He later joined CSR Institute of Himalayan Bioresource Technology, Palanpur, India as a scientist and was promoted to senior scientist. Currently, he serves as principal scientist at the institute and also acts as coordinator for ACSIR, an institute of national importance established by an act of parliament. He was a visiting scientist at the National Research Institute of Chinese Medicine in Taipei, Taiwan, under the Ministry of Health and Welfare. His work has been recognized by several awards, notably the P.C. Dandiya Award, Dr. Abhyal Award, and Saroj V.N. Sharma Award by the Indian Pharmacological Society. He is credited with the establishment of the Development Research Facility at the CSR IPT Palanpur, and his major thrust area is epileptology. His research group is actively involved in understanding the neuropharmacological behavior of natural products, and his research group is presently working on the development of natural product-based therapy for the management of epilepsy. He has published several articles in the international journals of repute and 5 patents, and he is an editorial board member and a regular reviewer of several international journals. So I request Dr. Damanpreet to please deliver his talk.
Thank you, Dr. Sangeeta, for this detailed introduction. So before I proceed, I just want to thank the organizer, especially Dr. Anil and his team for inviting me for this pre-conference workshop. And they have rightly identified a topic, that is the use of alternatives, because that is the need of future, because we all know what we observed during our PhD time, that we have lot number of animals to work. Our seniors, they have lot number of animals, different species to work. They have worked on dog, they have worked on other species. But we were left with rat and mice. And our students, I think, there are some incidents where even the children, they don't know, the students, they don't know what is the difference between rat and mice. Because in today's introductory speech, our organizing secretary, they rightly said that what we read we forget, and what we write it returns, and what we do it retains for life. So that is true, because now children or now the student, what they see, they just see their books, that rat look like this and mice look like this, but practically it is a little bit issue, and that's why we need alternatives. And I think our lab was the first, or I say few labs during the time we have started in 2016. They work on zebrafish. And once we started this facility, we faced a lot of problems, because at that time, I think even I also haven't seen zebrafish earlier. Because in our lab, what we do, we go for screening, because our lab is focused on Western Himalayan region, where we have lot number of natural products, and we go for isolation and then we go for screening. And this type of screening is not possible using the rodent model. And our seniors, they have asked that once I joined, that you have to start with an alternative facility. That is your choice, that you want to start it with Drosophila or you want to start it with zebrafish. The problem with Drosophila was that the feeding or dosing was a problem. You can just give in the feed, But for zebrafish, there are lot number of ways to give the drug. We can give orally, we can give IV, we can give directly to the system where the absorption is through gills or through the skin. So there are multiple options using the fish. That's why we opted for fish. And once we started, there was no clarity about the regulatory aspects. There was no clarity about the source of fish. There was no clarity about the genetic resources that are related to zebrafish. But thanks to our regulatory bodies, especially CCSE in India and other like OECD, they have started or they have recognized this fish as a model and framed separate guidelines that how we have to use. Now we have ZFIN database managed by University of Oregon, where we can get the genetic resources. So now, not wasting much time, I will start with my talk. It is from tank to data. Definitely from the tank we are generating the data. And tank can be the standalone system having 10 liter capacity, 3 liter capacity, or it can be a tank that is just small. We say 300 microliter, 96 well plate. Both are tank, both will give the same data. And that is the beauty of this fish. We need not to have so much of labs and veterinarian support. Simply, एक छोटा सा room है, it will serve our purpose. And I will try to show you the best I can do with the resources we have here after the post session. So this is just about my lab. This is the entry, and that is our regulatory facility where our zebrafish facility is located. And there are two images. You can see two types of fish. The first one is the larva of 3 days. And second one is the adult zebrafish of 3 to 4 months. And the beauty of this fish is that you can see all the organs present in the 3 days old and the 3 months old. And the 3 months old is equivalent to your rat. So we need not to wait for 3 months to start our experiment. Our model is ready within 3 days. And there are multiple advantages more that in these 3 days we get n number of fish. That is not possible with the rodents. So you can see heart, you can see the kidney, you can see the brain, you can see the skeletal system. Everything is available. Fine, but we cannot see the lungs. That is the difference. That is the limitation that will come. That I will come at the end of my presentation. So this is just a brief about our organization. I think you all are well aware. So this CSL, Council of Scientific and Industrial Research, it is an autonomous body in the Ministry of Science and Technology, having 37 national laboratories, 39 outreach centers, 3 innovation complexes and 3 units. And ISBT is the only lab at Himachal Pradesh, and our mandate is to undergo bioresources for catalyzing bioeconomy in sustainable manner. So, being it is a pharmacology, I will stick to drug discovery itself because the application of zebrafish is more research. But here I will just focus on drug discovery and development. So this is the whole story of discovery and development. I think you all are from pharma background and you know better that the whole story takes around 15 years to move a molecule from the lab shelf to the shelf of a chemist shop. And using this fish, we can just, because it has some disadvantages also. It is a non-mammalian model, and definitely when we have to test anything, we use a mammalian model. So this is a disadvantage. But still, the screening part or initial studies, we can shorten the time using the zebrafish. Fine. So these are the importance of animals in drug discovery. I will skip some slides because we are already short of time. So these are some of the important why we need animals, because we need a disease structure. We cannot use a human as it is. They have short lifespan. I have to do a study for example, the whole life. I need not to wait for 60 to 70 years. I can complete the whole study within 3 to 4 years of the animal, because child, adult and old age will be there in 3 years. And moreover, we can easily manipulate the conditions. I can in a single room, in a single lab room, I can generate the condition of hard desert. I can maintain the condition of high altitude, cold desert. That is the beauty, that we can manipulate the conditions. So it has some animals. They have some genetic similarity. In certain cases, it is around 99% genetic similarity. So these are the major domains where we need animals. I will again skip this. So this is the overall usage of animal in biomedical research. I have used biomedical research because there is no separate official data that how much animals are used in particular in pharmacology, what are the usage in zoology, and what is used in biomedical, in this other type of engineering. Overall, this is the status of animal use, and this is the official figure that I can get from the online portal. So if you see, there is 65% of mice that are being used globally, then followed by birds, rats, fish, etc. And on right hand side you can see the number of animals. These are the just official numbers that are available in public domain. Because in several times we do research and we don't convert that research from lab into the public domain. We complete the thesis and we put those theses in our library. They are not in public domain. And this data is available on the public domain. So you can see China tops the list. And the value is around 2 crore animals they have used. But again, it is we say not the true figure. The number will be, I think, 10 to 12 times more compared to this. And if we see India, it comes at around 17th or 16th position when we see it globally. Fine. So these are some of the concerns. Being a pharmacologist, being a person associated with biomedical research, and all of you. These are some of the concerns. Like if you see, starting from 2012, the first was government banned use of live animals for education and research. And that is true. You are fortunate that you are working in a university, but in colleges, hardly any student they see any animal in their lab at undergraduate level. Some are lucky they see at postgraduate level, but you all are lucky that you have at least seen the animals what they look like in the lab. And because government has banned the use of animals in 2012. And what happens after 2 years? India to end household product test on animals. So it is banned that we cannot test detergent, we cannot test any type of skin irritation studies on animals. So these are just, I say, the tightening of the use of animals. My friend from PETA is sitting over here and he will definitely talk why it is important to ban. It is important to ban also because it is not good to just to show anything to the students. If we see, we have a group of 60 students. It is not good to train all the 60 for animals because in future we are going to work with animals in future. So I think 50 or I would say 55 to 58, they will not use animal any time of their life. And I say, if you see your classmates, I think from 60, I think 1 or 2 are in the pharmacology field. They are working on animals. Some are in bank manager and some are in other marketing places. They may not be using animals. So that we need some policy where only those persons that are interested, they should be allowed to work either at graduate level and postgraduate level because we need the second line. And this is the last step. India takes the first step to remove animals from drug testing, and this report is of 2023. And I'm sure within 10 or 12 days, 10 or 12 years, we can see started a lot of projects to use organoid as an alternative, organ on chip, and other computational tools to remove the animal in drug testing. Okay. Now it is a little bit strict. In days to come, there will be need of replacements. So what are the replacements? As per CCSE or the global agencies that are working on this ethical use of animals, they have mandated this 3 R's theory: reduction, refinement, and replacement. I think you all are well aware. Reduction is I have to use 6 animals per group, why not 4? Refinement, I have to use 2 control, why not 1? Replacement, that is what we can do. Replacement is to replace the animal with certain other things. And there are 2 R's that have been added: rehabilitation, reuse, and this typically is for larger animals. And there are few other R's have been added, like rethink, like something else. And this is the replacement that we can do. And what are the replacements? These are the 4 replacements. To use an alternative computer-based system, it has its disadvantage because computer will tell what is happening at the drug site how drug is interacting with the receptor, but it won't tell how drug is reaching to that site. Use in vitro cell culture, the same problem. Use of animal disease structure, we can use this, but it has certain problem because here there are two regulatory bodies. It is a biomedical from one side and institutional ethics committee on the other side, because we have to take approval from IEC in that case. And the fourth one is use of less sentient animals. And what are less sentient animals? These are those of animals, we say those are less socially attached and that feel less pain. अब ये वाली चीज जो है ना, it is up to us. What we think they feel less pain, because animal is not going to tell us that the animal is facing pain or not. And we say that animal is not socially attached because after the birth the mother move aside, so that's why they are not socially attached. We don't know what is the feeling of animal. So earlier it was not clarity that what should be considered as an alternative. Some say earthworm is an alternative, some say butterfly is an alternative, some say larva of mosquito is an alternative, but there was not clarity. Anyone who says that this is an alternative, they start working on that model. But later on, this CCSA, earlier it was CPCSA because the notification came in 2019, and they have classified these 5 species as an alternative. So first one was zebrafish, second was C. elegans, then Drosophila, and 2 other tunicates and some starfish as an alternative. So then it was clear after 2009 that these 5 species can be used as an alternative. And being a pharmacology person or a person associated with biomedical research, I think all of you, if you see the list, zebrafish will be of interest. Because a little bit its structure or its anatomy, it is similar to mammal. But still there was no clarity, because in India, I think your teachers, they might be knowing what is the problem with the ethics when we use animals. India में तो बोल दिया use नहीं है, जरूरत नहीं है. But once we submit a publication, the journal editorial board, they ask for the ethics approval number. Then there was a question whether we need it or not. The same problem with me, because being a CSR institute, we have to follow each and every guideline for the government. So we started in 2016. I am just figures, because many of you will also face this, because I receive, I think on daily basis I receive certain queries from different researchers that are working throughout India, that what is required or what is not. We started in 2016. The first question was to procurement of fish. कहाँ से लेनी है अभी? दिखती कैसे बात ये नहीं पता. So from where we have to procure, and then after procurement, do we need an ethics committee approval or not? So I just started my career. I was just a PhD pass out, and I wrote a mail to a senior scientist of our area. I will take the name of that person. So I asked that I have read your paper and you have mentioned that we have used zebrafish and followed CCSA guideline, but there is no CCSA guideline available. तो सामने वाले को ऐसा लगा कि ये तो that person, he took that point on some other side. उसको गलत तरीके से लिया कि ये मेरे से पूछ रहा है कि बच्चा मेरे से पूछ रहा है कि एथिक्स वो ली या नहीं ली और कैसे ली. Because it was my curiosity, because I was facing the same problem. I just want to get the answer that whether there are some guidelines available that I may not be knowing. But later how we wrote to CCSA that what should we do. So they said you make your own guideline. In 2016, you have अपनी guideline खुद बनाओ and then send to us. We will endorse that and you then follow that guideline. So we were the first in 2017. We made our guideline and we sent it to CCSA, and they give us approval and then we started it. है ना? हम उससे पहले से ये approval ले, but यहाँ तक clarity नहीं थी कि क्या करना. Because it is not easy for each one of you to write mail to CCSA and get the information. We were lucky that we were working in CSI lab, and our seniors, especially at CCMB, they have started this fish facility, I think decade back. So in 2021, CCSA they published their own guideline on the use of fish. So इसके आने के बाद क्या हुआ कि anyone who want to work on fish, they have to take ethics approval. इसमें कोई assumption नहीं है ना. If we see the global guidelines, they said that till day 5, there is no vertebral column that has been developed in an embryo or in larva, so you need not to take approval. But इस guideline में ऐसी कोई assumption नहीं है. If we have to use the embryo, we have to take the approval. but it is not as much as stringent as that of raw net. And इसमें जो ethics committee भी होती है ना, it is little bit liberal. Fine. तो सबसे बड़ा क्वेश्चन कि ये फिश दिखती कैसे? See, I think you all are lucky that Dr. Avneet is here, but we lack an zoologist in our lab. है ना, हमें तो देखा भी नहीं था, because I have studied the same curriculum जो हम सब पढ़ते हैं, B.Com, M.Com, PhD, कहीं भी फिश का नामो निशानी नहीं, है ना, if I am not wrong, till the curriculum is same. है ना, I have studied in 2006, 8 and 2000 till 2013. After that कुछ change होगा मेरे को पता नहीं, लेकिन at that time there was no guideline about zebra fish कि वो दिखती कैसे और मिलेगी कहाँ से. So this is just for you, है ना. ये सभी फिश इंडिया में कहीं ना कहीं पेट शॉप से मिलती है. इसको ज़ेब्रा फिश कह के सब लोग बेचते हैं और सब लोग यूज भी करते हैं. सिर्फ दीज आर डेन्यू, है ना, जीनस सेम है, बट इट इज नॉट द सेम रेडियो स्पीशीज दैट वी नीड, है ना. तो फर्स्ट थिंग इज डिफरेंट, सेकंड इज डिफरेंट, थर्ड इज डिफरेंट, फोर्थ वन व्हाट वी रिक्वायर्ड, एंड देन टू अदर स्पीशीज. सी, ज़ेब्रा नाम ही इंडिकेट कर रहा है, इट हैज सम स्ट्राइप्स ऑन द बॉडी, सभी में है, बट ऐसी नहीं चाहिए. व्हाट वी नीड, इट इज, आई हैव शोन 2 photographs, SF and LF. This SF it is short fin and LF it is long fin. Long fin it is more of interest for aquarium, aquatic for decorative fish, but still people use this in their lab. It is a wild type, but it has a different mutation where the fin fold it open. I think Dr. Avneet will take this better because I am not the correct person. Those who know about fisheries. And the first one, it is short fin, that is what we require, and all the genetic resources that are available with the name of Denio rario, that are with this short fin fish. Fine. So जब भी लेना, fourth one what we require. Fine. So these are some of the other varieties that are being sold and are being used also in several other labs. देखिए, मैं बड़े मजे की बात बताता हूँ. When we started in 2016, कभी देखी नहीं थी fish. So I went to a pet shop. I asked for zebra fish. तो pet वाले को भी इतना कुछ नहीं पता, उसको बोला कि क्या होता है. तो I said stripes होती हैं, तो दानियाँ होती हैं zebra की तरह. तो he said नहीं, मिल जाएगी सर, मिल जाएगी, हमारा बड़ा बड़ा नेटवर्क है, तो we'll arrange. So आप मंडे को आना, ले जाएगा. So I went to, I procured it. तो उसने मेरे को कह दिया, फोर्थ वन वाली दिख रही है, लेक मारो दिख रही है. तो ये वाली थी उसने मेरे को फिश, बहुत छोटी थी उस टाइम. तो इट वाज डिफिकल्ट बिकॉज व्हाट वी सी इन ऑन इंटरनेट से तो मिलता कहता है. तो सर ये सेम ही है जी. तो व्हाट हैपेंड आफ्टर 2 months इट ग्रोन टू द साइज ऑफ 5 centimeter. तो 5 centimeter के बाद वो ऐसी दिखने लगी. सो देन आई टुक अ फोटोग्राफ फ्रॉम इंटरनेट एंड दिस फिश टू दैट पर्सन, पेट शॉप पर्सन, दैट आई नीड लाइक दिस. यार आपने तो ज़ेब्रा मांगा था, ज़ेब्रा तो ये ऐसा दिख रहा है, वह तो दिखती नहीं. It's obvious because in zebra it is not horizontal, it's vertical. तो ना ये zebra ज़्यादा दिखता है कि वो ज़्यादा दिखता है आपको? So then I came to know that there is some problem, that what we are trying to do, it is difficult because we need certain person from zoology background. Then we recruited a person with fishery background to start with this facility, and then first of all we procured it from Dr. Ramachandran. Then again there was we are facing some genetic problem, then we procured it from IGIB. So I'll later on tell you what are the problems when we use this. So this is how we correctly identify the fish. ठीक है. जो पहला आपको दिख रहा ना, तो whenever you have to start the facility, try to see this. किसमें ना stripes कुछ ऐसे दिखती हैं. There are 4 to 5 blue horizontal stripes with alternative golden to silver one. Fine. तो इसमें जो 2 दिखाई हुई है ना, जो सेकंड वन, इट इज अ करेक्ट वैरायटी. वी वांट दिस कि कुछ इस तरह से होना चाहिए उसकी जो स्ट्राइप्स है. दिस इज मॉर्फोलॉजिकल आइडेंटिफिकेशन. यू कैन आल्सो गो फॉर द जेनेटिक आइडेंटिफिकेशन, बट स्टिल जेनेटिक टूल्स आर नॉट अवेलेबल टू ईच वन ऑफ यू. सो सबसे अच्छा है कि देख के ही आइडेंटिफाई कर. एंड सेकेंडली जो दिख रहा मेल और फीमेल, सी मेल और फीमेल दे लुक लाइक दिस. दिस इज वेरी इंपॉर्टेंट. ठीक है, अगर आप मेल को देखोगे ना, थोड़ा लाइट में देखते हैं, तो जो व्हाइटिश टू गोल्डन लिखा ना, सिल्वर टू गोल्डन, सिर्फ गोल्डन वाला जो कलर होता है ये मेल में दिखता है. सिल्वर वाला जो होता है इट इज मोर प्रोमिनेंट इन केस ऑफ फीमेल. एंड मेल दे हैव सिलेंड्रिकल बॉडी एंड फीमेल दे हैव लिटिल बिट curved body. They have a belly just because of eggs, and this is the adult age. See, we actually for CCSA we are the sole breeder also in our region. We breed it and we sell it also because we are authorized for breeding and sale of zebrafish also. So क्या हुआ? I have sold certain fish to someone. ये तो 3 महीने में वापस आए कि यार ब्रीडिंग नहीं करी, आपने ओल्ड एज दे दी फिश. There was a question that what should be done, because what we did, हमारे तो पहला ही client था, तो we were little bit in doubt कि हाँ भी अच्छा दें, सब कुछ दें, because we have to make our new clients. But the problem was that they were trying to breed male with male and female with female. ऐसा तो होगा नहीं, है ना? Thing is the correct identification of male and female fish. So this is how you can identify. This is just a picture. So when we do it in the post-lunch session, I will try to let you know how we can distinguish male and female, because this is a major concern with fish. Because lot number of facilities, they start with using this zebrafish, but later on they close it down because the major thing is breeding नहीं होती और होने के बाद survive नहीं होता. And I think 2-3 of your PhD scholars, they also visited our lab and they have faced the same problem. You can have a better discussion with them. So these are some of the advantages. है ना? 30 minutes तक after fertilization they remain in single cell stage. So we can easily go for mutation. कि मैं किसी भी gene को silence कर सकता हूँ, whatever we can do, because it remain at single cell stage till 30 minutes. And after 30 hours post fertilization, majority of organs they are ready. You can see the eye, you can see the brain, you can see the swim bladder, everything is ready. And moreover they are optically a little bit transparent till this stage. So if they are transparent, we need not to have high-end equipment to see their movements, to see their growth, to see their expression. We can simply see under the stereo zoom microscope. I think we have arranged this for you all. Okay, how we have to identify the organs. You can see the beating heart. I have also brought some video for you. So this is the importance. So I have just taken the data of 10 years, which is officially available on PubMed. So you can see zebrafish that was at last in the year 2004. It tops the list of preclinical models when we reached 2015. And this trend will, I think it has doubled in last 10 years. Even in India, in last 10 years, earlier we were having 3-4 labs, but now we have, I think, more than 200 labs that are using zebrafish. And this is a trend in the usage of zebrafish on the papers that have been published on PubMed. So this is the importance. So these are the requirements. देखिए बहुत बड़ी आती है क्वेश्चन that we need a high-end standalone system, we need a separate system with filtration for zebrafish. ऐसा कुछ नहीं है. These are the conditions. If we can maintain it easily, we can grow the fish in any place. Fine. Temperature 25 to 31. See, जो मैं ये guidelines दे रहा हूँ, it may vary in different publications, but this is based upon our own experience. Because each lab they have to standardize their own conditions, but for our standardized condition, what we got this. So it must be between 25 to 31, but the optimum is 28.5. So if we have maintained this much temperature, it will survive. Conductivity 400 to 800 ohms, and ideally it is 600. In few publications you will also get 1200, 1400, but our fish they do best on this condition. pH 7 to 8.5, 7.5 is ideal. And for feeding, majority of researchers, they feed pellet feed that is available on commercial shops. See, if you want to work on neuropharmacology, avoid giving the pellet feed, because it is a wild fish that love hunting and eating, and वो शिकार करके खाना पसंद करती है. So it's better to feed it with live artemia to maintain its neurobehavioral function intact. आपके सामने आप खुद ही एक्सपेरिमेंट करो. In one group you just give the pellet feed and in other you give the artemia feed. The behavior will be different. And if you want to go for cognitive studies, you want to go for behavioral analysis, so always try to use this artemia, live artemia feed. कुछ इतनी महंगी नहीं है. Cysts they are available commercially. Just use a separating funnel. Irrigator लीजिए जो मार्केट से मिल जाता है 200-300 रुपए का, and put this cyst into that. Put some sodium chloride. बल्बिंग होने दीजिए, गिव इंटेंस लाइट टू दैट, एक LED लगा दीजिए उसके ऊपर, and after 24 hours and 48 hours, depending on the temperature, you will get the live RTG. That get easily separated with the light. Fine. And for breeding, this is a breeding setup what we use. You can see there is outer container with this normal base, and there is another inner container with perforated bottom. So what we do, we put that perforated bottom container in the outer container, and we fill it with water, and with a separator we separate into two parts. You can see top view and front view. From the top view you can see on one side there are 2 fish, and on other side there are 4 fish. So these 4, these are female, and 2 they are male. Again you have to standardize that based upon your laboratory condition, because some say that 1:1, 1 male and 1 female, they give better breeding. In some cases they say 2 male with 1 female, but in our lab condition what we observe, 2 female with 1 male, they give a good number of embryos and good clutch size that can be used in future. And this green, these are just an artificial plants, because it again is a wild fish, they get a hiding space, and what we observe that we get a good clutch size when we add certain type of these plants in this fish. Fine. So these are the stages. You can see from 0 to 30 days. I think all the organs are ready, because it remains an initial larval stage. This is a standalone system. इतना लेने की जरूरत नहीं है. I have also added. I will provide certain document to Dr. Sangeeta. I think she will share you. है ना? उसमें सारा कुछ दिया है कि how you can make a low cost zebrafish facility. What are the water condition? How you can maintain. ठीक है, कौन-कौन से diseases हैं, सारे डॉक्यूमेंट में मैं आपको देके जाऊँगा. She will hand over to you. Fine. So this is a standalone system which it automatically clean it automatically maintain the pH, conductivity, सब कुछ खुद ही करता है. अगर ये नहीं है तो we can also start with our own made system. So how we can initiate the experiment? Okay, now coming to the pharmacology point of view. Because in pharmacology, when we have to start the experiment, first we go for dose determination study. Then we go for the efficacy study, then we go for the toxicity study. So how we perform in this case? So here OECD, under test guideline 236, they have clearly mentioned how we have to go for the toxicity studies. Simply, we have to take 20 embryos, and on days, and after fertilization, we expose it to different concentration of our test compounds in system water. Okay, drug leak, just dissolve it in your system water and put 20 embryos with each concentration. And after every 24 hours, note down these growth parameters. Like after 24 hours, if there is no toxicity, there will be somite formation, tail detachment, and heartbeat. You can visualize it under simple stereo zoom microscope. And after 48 hours, there will be blood circulation and pigmentation. After 72 hours, there will be pectoral fin development and hatching from the chorion. And after 96 hours, there will be free swimming. And if any one of this endpoint is lacking in any of the embryo, just note down the toxicity. And simply how we determine how we perform the probability analysis, in the same way, there is a tool that is called as benchmarking dose level. Simply what we say NOEAL for our drugs, there we get the benchmark concentration. ठीक है, कुछ नहीं है, it is freely available. It is given by US ETA, free to use. Just put your values in this software. It will automatically plot it. It will give you 20 plus this equations that your data is fitting to this particular equation, and based upon this is your benchmark dose level that will make NOEAL. ये concentration है जिसके ऊपर toxicity कोई नहीं है, इसके ऊपर अगर जाओगे there will be toxicity. And upper safe level and lower effective level. Fine. So here you identify your BMD, the safe level, and you start your activity at any concentration below that. What we do, we go for 1/5 of that. Fine. So this is the simplest method where we can get the toxicity, where we can have our effective dose within 4 days. Fine. So these are some of the advantages of using zebra-fish modeling in academic research, because I think you all are related to academic research. That's why I have particularly chosen the advantages that are specific to academic research, and here I will just show my own example, because I think sir in today's talk rightly said that पढ़ेंगे तो भूल जाएंगे, and if we read we'll forget, we write, then we remember. So that's why I have just given the correct examples where we face the problem and these are the advantages. So its first advantage is high genetic and anatomical similarity. I think I have already shown. It has a lot of genetic and anatomical similarity where I need not to have much examples. Next is less ethical constraints. See, this is for neurological studies. You can see three brains. We have a brain of rat, we have a brain of human, we have a brain of a fish. So the beauty is that all the nuclei of the brain that are present in human, they are present in rats and that are present in fish. So it says that when I am using a mammalian model, I expect the same results what I am expecting in a rat, and that will be translated to human. This circuit that I have shown, it is for noradrenaline, dopamine, histamine, means these all our circuits are present in the fish. So all of the drugs that I am using, either it is for SSRIs, I have tricyclic antidepressant, I have whatever I want to use that are targeting these neurotransmitters, they will work in fish also. So I can use it for screening too. So this is another advantage. Like I have said, less ethical constraints. कभी भी ethics committee के पास जाएं, अभी especially, if I will say I will use 8 animal per group, they said, करके दिखाइए कि how you have calculated the power, how you have calculated the sample size estimation. We do theoretically, but practically वो ऐसा नहीं होता, especially for neuroscience, where there is variation is more. Fine. So in that case, we want more number of animals per group. कभी 6 से ऊपर देते नहीं. We say 8, they will say 6. We will say 6, they will say why not 5. We say 5, why not 3? Why not remove a control? But here you can use it because the size is very small. Size is 1 millimeter. And here I have just given an example that where we have tested a molecule for epilepsy. How we observe it and how much number of animals and how much control we use, and that was accepted by the journal, that was accepted by the patent cell authority. And it has been patented, it has been published. Fine. So simply I think you all are from pharmacology background, you know what is tonic seizure, what is clonic seizure. Rat में सबने किया है, अब fish में how it look like. देखिए simply क्या है, इसमें we use a simple 6 well plate. You can see that plate. Left hand side पे जो एक plate देखिए 6 well plate है. 3 ml की capacity होती है इसमें, and at the top we have fixed a camera. Fine, and it records the behavior. So when we use pentylene tetragonal as a chemoconvulsant, it induces seizures. Rat में we know how it will show. It will show stalk tail, it will show you flexion, it will show you unilimb clonus, likewise. In fish we will get in larva we will get 3 stages. First is hyperactivity, and second is whirlpool-like behavior, and third is clonic-like seizure. Hyperactivity, you will see easily that it will start moving fastly. And for whirlpool, it look like this. Okay. So can I have use the time?
So we are running late. So
Okay. I'll just I'm completing 5 minutes. So you can see the larva is revolving on its own axis. And there's a washing machine with a whirlpool type. So you can see the whirlpool type movement. And the last stage is you can see the clonic seizure. You can see the larva. It is jerky movement that is just because of contraction in the muscular structure. Fine. So here we have used 12 number of animals in each group. Each group with pentylene tetragonal, each group without pentylene tetragonal. For means a separate control for each group. Now we cannot expect it using the rats. So this is the data, because when the larva moves, it give us a track, and with this track we can calculate what was the hyperactivity, what was the distance traveled, and what was the latency to clonic-like seizure. And biochemistry we can also do for genetic studies and all those things. And secondly, for screening, we can also use it for screening. Like I have prepared 10-12 molecules. We cannot screen using rat. Here we can use it as a screening tool. Fine, I am skipping the slide because I have been asked to summarize. So you can see the data from the screening. It was accepted with the journal, and it was accepted in most of the countries because the data was patented in, I think, all the countries. Japan, US, India, PCT, everywhere. So means it has acceptability. I might just here, my aim is to let you know that it has a wide acceptability. No one is going to challenge it, but we get the results out of it. And the next thing, it is highly cost effective. The screening cost is very less because I think rat it costs around 500, 400, 500 rupees. Mice it costs around 200, 250 rupees. But here the fish cost it is 12 rupees, and the embryo I think it will be less than 1 rupee. And moreover, the test drug that we need in rat will be around 10,000 times less as compared to rat with the fish. This is one of the examples. One of my students, Arindam, he did his PhD, and during his PhD work, he was to give an injection into the heart. So he came to me that here he is facing some problem because it become easy to inject drug in case of heart of epileptic animal, and it was easy to inject in case, it was difficult to inject in case of normal rat. So thing was that if we see the epileptic heart and if we see the normal heart, there was some problem because epilepsy was inducing certain changes inside the heart, because of which it got dilated, and it was easy to inject into that. So to find out this, we did, this is just a background information I am skipping. We carried out whole transcriptome, we studied the whole proteome, then we studied the network analysis. Ultimately what we came to know that there was upregulation of certain mammalian, this mechanistic target of rapamycin. I won't use mammalian target of rapamycin, but here it is mechanistic target of rapamycin. It was overexpressed. And here the option was use an inhibitor to inhibit this, to find out the condition, what exactly is happening. But if I calculated the cost of that inhibitor to carry out the whole study in rat, it was costing around 50 lakh rupees. So practically possible because it was as same as that of the cost of the whole project. So here we first where we used the fish model. In the fish model, the problem here is it has fast regeneration. So it becomes difficult to model chronic diseases using zebrafish. This is a big disadvantage. है ना, क्योंकि जितनी देर में वो इंड्यूस होगा उतनी देर में वो रीजनरेट कर जाती है. That is with the epilepsy, because epilepsy is a chronic disease. In rare in certain situations it is acute, but clinically it is a chronic condition, and it becomes difficult to model it in a chronic conditions. So that's why first we develop a new model. So she is my student. She developed this model. It was published also. It is similar to that of mammalian model. It is a human epilepsy. So based upon that, she worked with under ACSI RMIT fellowship in Australia, and she extended this work there also. And we use this model to validate our hypothesis, and this was the outcome. And last thing where I say it is again it has the advantage that it is a transparent structure. Embryos and especially early larvae, it is transparent, and in case of larva we can also inhibit the pigmentation by using a simple inhibitor. So this is again advantage for academic research. We need not to have certain the high-end imaging system to record the in situ changes. We can use simply, we can use embryos, we can use larva for this in situ analysis of internal structure. So here I have just given the example of intracerebral hemorrhagic stroke. And if we have to induce the stroke in rat, and then we just based upon the behavior we analyze क्या ऐसा हो सकता है. Might be there was a hemorrhage, or we have to go for histologically after that. But in fish we can directly see where is the hemorrhage inside the larva, inside the embryo, just in 24 hours post fertilized embryos. This is the whole story where we used embryos, we removed the chlorine, we treated with an agent that called hemorrhage, and you can see this ornithine anodizing stain. You can see under simple steel microscope you can see the hemorrhagic stroke. So again it was, so this is another example. You can, like for cardiovascular pharmacology, like we have to note down the heart rate, we can note down the ejection fraction, we note down the other cardiac parameters. Here you can simply use this model. I think you can see the beating heart. A simple exterior microscope है, उसके अंदर at 3 days post fertilization you can see the beating of heart. And with this beating you can record n number of parameters. Okay, पहले तो इसमें heart beat पता चल जाती है. You can manually record the heart beat. 10 seconds के लिए किया, multiply by 6. And secondly you can see these. You can take the photographs. 1 मिनट में हर 1 सेकंड पे या हर 5 सेकंड में take the photograph. है ना? Randomly in between that photographs एक टाइम पे ऐसा होगा जहाँ पे heart का साइज बहुत बड़ा, एक टाइम पे होगा कि heart का साइज बहुत छोटा. There are 2 images, like top one and lower one. यहाँ पे बहुत ज़्यादा it is your systole and जहाँ पे जिस पे बहुत ज़्यादा that is your diastole है, जहाँ पे सबसे कम है that is your systole. अगर यहाँ से इसको माइनस करेंगे तो बाकी वॉल्यूम निकल जाएगा and that will be your ejection fraction. है ना? We have an equation where we convert this 2D into 3D and we note down the ejection fraction. Now try to think it with the rat. You need special echocardiography. You need the technician to note down this. ठीक है? So I won't take much more time. This is my last slide. These are some of the problems that you may face. इसी वजह से क्या है कि majority of labs they close down. First thing it is unknown mortality, and that what we observe that this mortality is just because of water conditions, infections or some other minor reasons. Or behavior बहुत common है because people they use different fish. Data we are following what is available on literature, but we are using different fish. It will not show the same behavior what it is reported in literature. And same is with genetic. कि genomic resources जो है वो different है and available are different. And larval death, this is a it seems this is I think Dr. Raneek might tell better what exactly it is, but this is usually available, usually appear in animal this zebrafish husbandry. You can see this worm. What we observe it is P. tomentosa. Might be, we are not sure, but ये आता है जब आए तो just clean your straw. Okay, otherwise you will face the problem. This is a simple construction of a zebrafish system that you can develop in your lab. I will share the document with ma'am. You can get it, and if you want you can start, and if you face any problem you can write to me and you can talk to me also. So these are some of the limitations. Definitely it is non-mammalian physiology. There are some anatomical differences. We don't have lung, we don't have prostate, we don't have mammary gland, non-placental and great regeneration capacity. It is advantage and it is disadvantage also. And these are the documents that I will hand it over to the organizers. You can get it. It is modular, easy to assemble, low-cost zebrafish facility. Document related to that, guidance on housing and care of zebrafish, regular care and maintenance, water quality parameter, how to establish this facility, OECD test guideline 236 to start with the experiment, and CCSA guidelines on zebrafish that they have published in 2021. So thank you very much. If you need more information, you can directly call me also, you can write me also. I am always available, especially when you want to ask any question related to zebrafish. So thank you.
If you have any question, you can ask during the tea time.
Thank you, and I welcome you all to IPC. This is a tulip garden. I think it is the first and only tulip garden in Himachal Pradesh. So I welcome you all if you want to visit it. So we're going to start it in February each year. From past 3-4 years, we are making it open to all outsiders. But I welcome you all if you want to visit that. Thank you very much.
Thank you so much, sir, for your insightful and engaging presentation on zebrafish. You covered every minute details of zebrafish, like its identification, food, housing, and the conditions which are really useful to proceed with. I truly believe that it has enriched understanding of this powerful model organism. Now I request Dr. B. Kalakumar and Professor Kabalji Chopra to felicitate Dr. Damanpreet Singh with a token of gratitude.
for adding it.
Zebra fish needs to be visible.
We are fine.
Sir, yes. Sir, yeah, please. Wait, kara, sir, yes. Thank you.
Daman has his heart and soul into the zebra fish. So, you know, this is very important for a scientist. You have to be passionate about the. You are going to see the passion of another scientist, Dr. Javneet Kaur. But this is a very important thing, that if you are passionate about it, if you are liking about it, you will dive deep into it. So adopt it as your, like I always tell my students, जैसे एक माँ को अपने बच्चे का सब पता होता है ना, इसी तरह से आस पास का सारा कुछ पता होगा zebra fish का. तो उस तरह से.
Thank you so much.
May God bless you.
Thank you, sir. Now, our next speaker of the Meet Kaur, and her talk is on exploring zebrafish as a regeneration and nanotoxicity research. And there is a brief introduction of Dr. Ravi.
I will introduce myself.
Okay.
I will introduce while So I think so. If you can switch that mic, I can talk. You people can hear me. If I stand here, I think so. It will be better rather than that. इसको switch off कर. ये आवाज़ जो आ रही है. So I am basically, and whatever Damanpreet sir told was remarkable. In fact, he had really identified the fish very well, and in practical session also you will see that you will be able to we will be able to help you out in identifying. I am here just to inspire you that you use our zebrafish. Okay, I am a fishery scientist, so I want you all should see what small things I have done in my lab and how I am using that zebrafish. So with few examples and few things I will add as a fishery scientist, how you have to identify, and same problem what sir also told, we also face the same problem. Sir, fortunately in 2016 only I started working. In 2015 we thought. Then sir, Dr. Ramachandran from ISER, he was the one who really helped. He helped you also and he helped me also. So I really want to thrust area, that is I will talk about the neurobehavior and neuroregeneration and nanotoxicity, how I used in these three fields, how I used zebrafish. Next. More pointer.
That's what it is.
So, I basically work on zebrafish neurobiology and toxicology. I try to develop a retinal regenerative model and try to study the regeneration pathway in zebrafish. I also created a chronic stress model, and we've worked on that, and presently we are working on the pink mediated mitophagy pathway in zebrafish. I will not go in details. And I work on river Satluj and the water bodies of Chandigarh, where I'm working on the nano and the microplastics. So I'm taking zebrafish as a model to study its toxicity. And my third area is I use fish scales as a biomaterial. I work on two cardinal molecules, that is collagen and hydroxyapatite. So when I talk about hydroxyapatite, these nanoparticles which are made, I try to study its toxicity in zebrafish. So then we can say the fish are really just little people with fins. So if you want to identify a fish, you have to see whether it has a fin, and those fins should have fin rays in it. If that is there, then it is known as a fish. And interestingly, 70% of the genes are similar, whereas 80% of the diseased genes are similar in humans and zebrafish. So this is a person, George Streisinger. He was from University of Oregon, and he worked on, he was a very passionate lover of fish, and he had aquarium in his room in lab, and he used to see his breeding, and he is after seeing those transparent lovely embryos, he started working on them, and in 1970 he proposed zebrafish as a model. And today he is known as the father of the modern zebrafish research also. Taking into consideration the ease of its breeding, the NIH also started funding this model as a biomedical model for studying for toxicological and various studies. So this model got funded from NIH. And recently, if we see the development, you can see if we compare the zebrafish and the mouse, the publication has increased in case of zebrafish. And we have approximately 3,250 research institutes which are working on zebrafish across 100 countries. And they all are working in toxicology, pharmacology, cancer research, neurosciences, genome editing, gene expression, and blood-brain barriers also. And major is in developmental biology, and we have molecular, cell biology, and neurosciences. So this is very interesting, and we should be proud of this, that this particular fish, which is zebrafish, which was seen in University of Oregon, is basically our own fish, which is present in, it's a native of Southeast Himalayan region. And Hamilton, a very renowned fishery person, in 1822 identified this, described this fish taking from Kosi River in Bengal. And again, we also, when we started our work, and I went to a pet shop, I also asked, I want a zebrafish. So he brought me these so glowing zebrafishes, and these are all transgenic, beautiful one. I said, no, I want blue one. Next time again I went, he brought me all blue. Get you a stock from the wild, and when I got a wild stock, again I got a heterogeneous stock. There was albino, leopard one, and long fin one. So these were again bit upturned, so it can take a feed which is going to be floating. But as sir also said, that we prefer live food that gives better results than the pellet one. But pellet, if you want to feed them with pellet feed, there should be floating pellet feed should be there. And the other characteristic feature is it has incomplete lateral line. So if I will show you there, they have any fish has a lateral line, and this lateral line is going to be till here, till this is a pelvic fin, and till here you will see the lateral line. In other fish, it is still the caudal peduncle. The lateral line is still the caudal peduncle. And then the 5, you see 1, 2, 3, 4, 5 to 7 longitudinal striations of yellow, blue, and it can be golden or silverish depending upon the female or the male. They don't have this sexual dimorphism is not there. So you cannot identify whether it is a male or a female only during breeding season you will be able to know whether it is a male or a female. So before we go into the aspects studying a zebrafish as a model, we should know the developmental insights, and we should always create a development timeline. Unless and until we know what is normally happening, how we will make the difference, what is happening in our model. So for that you should know that the zygote is there, which is within the half an hour there is a single cell stage is there. Then we have this is a cleavage period is there, where the cell starts dividing, 2 cell, 4 cell, 8 cell. Then we have blastula stage, where we have the cells start dividing. So there are deep cells and enveloping cells are there. So these are the cells which are developing. We have early blastula, mid blastula and late blastula. And we have then gestulation, that is from 5 to 10 hours. This is important, that is the shield stage. It is very, if you have studied developmental biology, there is a dorsal lip where from where the axis is going to be defined. So in case of zebrafish, we have the shield stage, that is at the 6th hour we get this. And then this is a segmentation period from 10 to 24 hours. And here we can see the development has started. This is a part, pointer please. Okay, so that's the part where you can see the somites have started developing, and there's a primordium eye is there. Still the eye has not developed fully, and brain has been differentiated into Thielen, Dian and mid brain is there. Then we have pharyngula period. Pharyngula period is, if you see the mouth part which is developing, there are visceral arches are there. So arches, pehla arch hota hai mandible, second is going to be your hyoid, and then we have the branchial arches are there. So at this stage, it starts developing, and we have, if you have to identify, you can identify them by the pigment cells. So pigmentation starts, and the pigmentation maximally it starts in the retina part. Then circulatory system is formed, and heart starts, you will be able to start, you will be able to see the heart, it has started beating. Then hatching period is from 48 to 72 hours. And here again organogenesis is nearly complete except the gut, and we come to 96 hours, where everything is mostly all the organs have been formed except your mouth has not developed yet. On 5th day the zebrafish, they develop their mouth, and now it can live an independent life. It can without the yolk it can come out, and we can now feed the artificial feed also. So this is how it looks like. So this is how the cells are developing under the stereo microscope. We will show you under the stereo microscope how the one cells, then there is a 2 cell stage is there, and how the cells are developing. This is a blastula stage, cells are dividing. And in gestulation stage, there will be 3 germ layers which are going to be formed now. We will see the shield stage will be there. Now the cells are dispersed, gestulation has started. This is a shield stage which is there. Then we have the segmentation phase, where now the segmentation has started. And now pigmentation will start. So you can see how the pigmentation is taking place. Heartbeat has also started, neuron cells have developed. You can see the heart beating there. And then we have an independent, the larva, the fry, which is very small, which comes out, and it now starts feeding. So that is what the basic aim for telling you about the development is, that if you want to work on any brain, eye, anything, you need to have the timeline for that. You should know at what time what is happening. So for example, if we see on the 0th hour there is a formation. If you want to study the brain, on 0th hour there is a neural plate which is formed. Then we have the second is the neural keel is there. Then neural rod, neural tube on 18 to 24 hours post-fertilization. 22nd hours post-fertilization, you can see the cerebral primordium has been formed, and in 2 days, you will see the brain has been developed and you can recognize the lobes. Now I will talk about few pictures which will keep you motivating, awake you up also. And this is the neurobehavioral insights of a stressed zebrafish. So these my articles were published in Annals of Neurosciences and Physiology and Behavior. So we try to create a stress model. Stress model means we try to give zebrafish different types of stress. Every day new stress was given. It should not get habitual of that particular stress. So we had selected a restrained stress, heat, cold, social isolation, overcrowding, tank, net chasing, pheromones, predatory and dorsal body exposed. Every day randomly we selected 2 stressors we used to give the fish. The aim is no stress should be repeated, that a fish should get habitual of that. ठीक है, जैसे हमारे को अगर तो रोज नए कोई बॉस डांटे, कभी कोई डांटे, तो हम वी आर स्ट्रेस्ड, मगर अगर एक ही बॉस रोज डांटे हम हैबिचुअल हो जाते हैं, हम कहते हैं उसी की गलती है ना. सो वो नहीं हमने करना था, हमें उसको स्ट्रेस देना था कि वो स्ट्रेस मॉडल बनाए. तो यहाँ पर जब when we started seeing, this was the novel tank which is there. So the fish was taking all the showed time spent on the zone, different zones, entered the top zone also, distance traveled. But you see what is the condition of the stress free. Yes. So in case of the stress fish, repeat again. पीछे लेके जाओ इसको. ये normal है. So देखो, the fish is trying to stay at the bottom only, and after that it freezes. Still the video is going on, but the fish is not moving. So it showed that now our fish was stressed. Same goes for the shoaling behavior. So this is a normal. This zebra fish likes to make a school or a shoal. So they live in a group. और उनका एक distance होता है, that is known as the nearest distance which they have to maintain. But in case of the stressed one, you see the area covered made by the stressed fish. So we could make out that they are restricting their movement also. And here is the light and the dark test. And in case of the normal, the normal fish, this is a normal fish. It likes to swim in the white zone, black zone, dark zone. But in case of this stressed, when we expose them to the light and dark period, the fish prefer to stay in the dark zone. You can see from the fish track software which we have tried to track the fish. So it is preferring to be in the dark zone. And then we started doing its microscopic study. In the microscopic study, we started, we dissected the brain. We did the light microscopy, we identified different types of cells, and then we did the electron microscopy where we identified the myelinated axons. We also did the synapses one part, astrocytes were there, dendritic spines and mitochondria were studied. So I will show you some beautiful photographs. So this is the Golgi apparatus of normal telencephalon part, and this is the Golgi apparatus is there. With the mitochondria, ribosomes are there. This is the myelinated axons where I was interested, myelinated axons, and these are the astrocytes with the oligodendrocyte cells are there. And this was the fish RBCs is nucleated. So in the RBCs you will see nucleus. So this is a blood capillary showing the RBCs in there. And then we had made a timeline for what myelination, how the myelination, what time it takes for a fish to recover. Because fish is a regenerative model. It can regenerate its nervous system. So then we studied and we said that with first 18 hours of post-fertilization, first Schwann cells are there, then oligodendrocytes, then there is a beginning of the myelination by the oligodendrocytes, they start forming, and then we have the robust, that is the spinal cord is there. This is what happens in the stressed fish. So myelin sheath infolding, splitting, and bubbling was there. In the even double circles you could see. And we started studying on the diameter, what is the G ratio, that is the diameter of the axon with that of the myelination, and we could measure and said that it was more than what the fish with the normal behavior was there. So this is, and then remyelination also. So this is a normal with a stressed myelination, and the process of remyelination has started. Mitochondria also, you see, it's a normal mitochondria, and in the stressed, they are the swollen cristae are there. This is a synaptic region, post-synaptic and pre-synaptic region, if you can see this part. So this is the synaptic, and if you see in the stressed, it is increase in the presynaptic densities there. It's more darker if you can see, and reduced synaptic width is there. So synaptic width is also reduced. And zebrafish we study as a regenerative model. It can regenerate its brain, retina, spinal cord, fins, heart. And coming to retinal regeneration, normally we create a model by giving them a pesticide or a heavy metal, or we have given a high dose of fructose which releases ROS, and then it can lead to its mitochondrial, metabolic and physiological disruption and cause retinal damage. So if the retina of mammals are damaged, there is no regeneration is there. But in case of zebrafish, some genes are conserved. These genes are conserved, and they can reprogram or activate Muller glial cells to again form the retina. So the interesting thing was that initially I was working on Cyprinus carpio, a fish, where we saw the retina. We could see the degenerative model with the pesticide, but there was no recovery. It was a progressive degeneration. Interestingly, both these fishes are from same family, Cyprinidae. ये एक ही family में है, मगर सिर्फ zebra fish है जो regeneration दिखा रही है, and this fish never showed. It never showed in the electron microscope also. These are the rods and cones. And in transmission also, there was a progressive degeneration in the recovery group also. So no regeneration was shown. But interestingly, in zebrafish, when we started working, there was a degenerative model which was formed, and it regenerated after 15 days with self-recovery. Nothing was given, but only they recovered. Again, in SEM also, we could see the rods and cones were recovered. Transmission electron microscopy also validated it. And we also did the silver staining, where again we could see that there is a retinal attachment. If you see this, there was a pigmented epithelial layer is there, and photoreceptor cells is there. They basically, when they lose, that is known as retinal detachment which takes place. But in case of this, we could see. And when we had tagged with the Muller glial cells, we could see regeneration taking place in immunohistochemistry also. There were upregulation of some of the regenerative genes we could see. And in case of hyperglycemic retinopathy model also, similar results we could see. And this is what we have done in the optomotor response, where this model could not identify the light and the dark strips. Whereas if you see the model which was having the retinal detachment was not able to make a proper moves. Next. So now coming to the last part, where we have used zebrafish to study the nanotoxicity. That is, we breed the zebrafish. Breeding is very important. You should know that your strain is free from all diseases. Those nematodes, if they are taking place, you have to reject that batch. There is an acclimatization process also, which we will discuss during, in the evening we will do that. And here when we take it, we try to study the control, then the LC51, we take 1/6, 1/3 and lethal concentration 1. So this is what is happening to the zebrafish. The toxicity, when we had given a nanotoxicity, this was a control part, and in 24 hours we were expecting that these all should get pigmentation and pharyngula stage should have started, but we saw the deposition of those nanoparticles which were on the chorion layer inhibiting the enzymatic, and it was inducing hypoxia in this condition. And in case of the highest synthetic nanoparticles, if we see hydroxyapatite nanoparticles, there was premature hatching, and hyperemia was flushing of the the blood in the organs, and they were developing very fast. So in case of control, the one which we were studying was showing a better results, whereas in the synthetic one, it was low pigmentation was there, pericardial edema could be seen. And in case of the 72-hour stage, we could even see that normal fin development should have been there. It was quite normal in these two cases, but you see the synthetic one with the edema, yolk sac edema, and a little curvature in the spine, retarded fin. This is a fin which was supposed to come here, but it has not developed. And then we, at 96 hours, we could see a malformed spinal curvature, yolk sac edema, malforms. This your spinal curvature was there. And in 120 after 5 days, we could see that the curvature, the spinal curvature with a retarded period, this pectoral fin was there. These are some of the parameters which we wanted to add in the OCT guidelines, because if we try to compare it with the OCT guidelines, they say if there is an acute toxicity, they just take the consideration of coagulation of embryo, lack of somite formation, non-detachment of the tail, and lack of heartbeat. So these were the 4 parameters which were given by the OCT. But when we study that, sir said that CPC guidelines were improved, we should always work to improve our guidelines and have a better, so that we create a better model and we can understand this model. So this was what the toxicity test with the help of OCT guidelines we had concluded. So that was, and this apoptotic cells on 5th day we had stained it with acridine orange. We tried to study what were the apoptosis. Synthetic showed, yellowish color showed that more dead cells were there. So that's all from my side. We are thankful to our students and the FISH model and the agencies which have been sponsoring us, and my lab mates, they are really working hard with this. And what all Damanpreet sir said, we also had the same problem when we started working. Still sometimes it becomes difficult for us to maintain that model. So if you have any questions, we can.
Any questions?
Any questions? Thank you, Dr. Ravi, for such an insightful talk on zebrafish, covering its developmental timelines. Your and Dr. Damanpreet's talk has really sparked an interest in us also, that we at UIPS should also establish such a facility on zebrafish, because we are lagging behind. And since this model organism can be used for many disorders like neurodegenerative disease, regeneration, and epilepsy, metabolic syndrome, and whatnot. So thank you so much, ma'am. Now I request Dr. Rajesh Ramachandran, Dr. Banappa, Dr. Damanpreet, and Dr. Besh to felicitate Dr. Avneet. Dr. Rohit, Dr. Kalakumar. So we can have a photograph together.
Please, sir.
Sir, throw close, please. Throw close. Yes, please. हाँ जी, yes, look here. अब wait करना चाहिए, yes. Thank you so much. Once more, ma'am. Yes, look here, everybody. Sir, yes, please. Thank you so much. Very nice. Yes, it was very nice.
So we'll break here for a cup of tea. And so I request all of you to please quickly assemble after 15 minutes. So because we are running late. So we'll start session at 11:45. Dr. Rajesh Ramachandran, Professor, Indian Institute of Science Education and Research, Mohali. Dr. Rajesh Ramachandran is a molecular neurobiologist specializing in zebrafish retina regeneration. He obtained his PhD in growth hormone gene manipulation in fish from the Center for Cellular and Molecular Biology, Hyderabad, following an MSc in Marine Biology from Cochin University of Science and Technology and a BSc in Geology from the University of Kerala. He has over 15 years of academic and research experience at IISER Mohali and previously conducted NIH-funded postdoctoral research at the University of Michigan, USA. His primary work has elucidated the molecular and genetic mechanisms underlying neuronal repair and glial reprogramming. Dr. Ramachandran has published extensively in high-impact journals such as Nature Cell Biology, Cell Reports, GIA, and PNAS, with significant discoveries involving the lead 7 miRNA and Hippo-YAP signaling pathways. He has guided many PhDs and postdoctoral scholars and continues to lead innovative research in developmental biology, epigenetic regulation, and regenerative neuroscience. We welcome you, sir, and with these words, I invite Professor Ramachandran for his talk.
Thank you. Good morning. For any reason, I find it difficult to stay away from home. So since it is local, so I decided to attend, and I don't regret my decision because I already heard 2 exciting talks. Today's my talk is on basically on 2 model organisms, and so the title of the talk is how histone deacetylases (HDACs) they can influence the immune cells. So as this 2 speakers before me already mentioned how important the zebrafish say regeneration model. So our focus is to understand how zebrafish is able to perform a regeneration or a tissue regeneration which we lack, the mammals lack, even mice which is one of the robust species which lacks regeneration. But all the mammals have the ability to regenerate the liver, and which is not the perfect epimorphic regeneration, but which is a compensatory regeneration. In a nutshell, you have 5 fingers in your hand, 3 fingers are cut. Ideally, those 3 fingers should come back, but instead, these 2 fingers will grow big and occupy the space. That is basically compensatory regeneration, but for liver, that is good enough. Other than that, we can grow maybe your hair, nail, etc. Very simple organs. We cannot regenerate any complex organs. So we are trying to understand how complex organs such as central nervous system is being regenerated in zebrafish, and how it is not happening. Just like the popular saying goes, the winners never do different things, they do things differently. So that is what we understand. These animals don't have any unique genes, they don't have any special genes which is unique to them, rather their expression pattern. Like one simple example I will tell you, after a retina regeneration, retinal damage in mice which don't regenerate, but immediately the genes are turned on which is helpful for regeneration, but maybe after a few hours they come back to normalcy. That means the initiation is there, maintenance and propagation and completion is not there. So we use these 2 model organisms. The first one is zebrafish, the second one is axolotl, a model which we established in 2019. And this, I had a passion for studying limb regeneration. However, that was not established in India. I looked out to various labs and I could find no labs have got axolotl, which is an amphibian model, excellent regenerative capacity, which is exclusively found in one lake in Mexico. So we imported it, and now we have a surplus number of axolotl, and we are close to publishing some of the interesting results, and that I will be presenting today. which is common in both the animals. So the outline of the talk, I will give a brief background, and also then the involvement of HDACs and the LED7 microRNA during retina regeneration in zebrafish, and then the immune cell dynamics during tissue regeneration in axolotl model. Please feel free to stop me. I have a habit of speaking more, so please stop me, give me some clues so that I will stop abruptly. So a few of the retinal disorders that we see in humans is retinitis pigmentosa, macular degeneration, cone rod dystrophy, retinal separation, etc., etc. And there are some of them are genetic, which is not due to any physiological disease condition. But in all these cases, all major retinal problems in humans that leads to irreversible blindness. If something goes wrong with your cornea, you can replace it with a donor, but you can't do nothing. And glaucoma is one of them, and even the hypertensive retinopathy is another issue. So what are the major possible solutions? So one is gene therapy. If it is a genetic disease, a gene is affected. These days, because of the CRISPR-Cas9 technology, you can happily edit that gene and get it fixed. Other option is stem cell therapy. A damaged area, you dump the stem cells, they will make the damaged part. And third is electrode transplantation. With some partial success, you implant some electrodes so that it can sense, they can avoid some objects that is going to come and hit on their way. So the best thing is to have the regeneration of retina from the resident population of stem cells. Even though when you put stem cells inside, we don't know, it's a novel thing and it may or may not differentiate. Sometimes it may lead to some gliosis, etc. So the best thing is resident population cannot be fixed, for which we need to have the understanding the mechanism of regeneration using animal models. Plenty of models have been used, mammalian, avian, amphibian and fish models. But only the amphibian and the fish models have the innate ability to regenerate. Although people use chick, that is the postnatal chick embryo, which have the ability to regenerate, and also the mammalian. So the mammalian regeneration literature is exclusively copying or simulating the discoveries of mice, discoveries of the zebrafish, try to copy in mice and see whether it is working. And almost all of that approaches were positive in mice. And they, since it being mice, they were able to publish in extremely high impact journal, although it is not regenerating. The reason being very simple, because we are mammals and any literature in mammals is having more impact rather than, even though it doesn't do regeneration on its own. And even today, we are not in a position to make a mammalian retina in any species to regenerate. So zebrafish, the previous speakers already talked about the importance. I will quickly go through it. It can reproduce year-round, external fertilization, transparent embryos, etc., etc. But the most important feature is the last 2 points, that is the zebrafish and human share extensive genomic homology and synteny, and the zebrafish can regenerate the central nervous system neuron following a damage. So these 2 important points makes them an attractive model in regeneration biology. So if you look into the structure of the retina, it's a cartoonish structure, and what you see in yellow color is the retina. And if you look at the ultrastructure, the outermost layer is the photoreceptor layer. Then you have a black color retinal pigment epithelium. Like if you see through the eye, you see black in color, which is because of the retinal pigment epithelium. And immediately close to the retinal pigment epithelium, you have got rods and cones, which is marked. And then in the inner nuclear layer, you have got horizontal, bipolar, amacrine cells are there, and then you also have the cell body of the Mueller glia. Neurons have got 6 different types of neuron and only one major type of glial cell. Glial cells are basically the assistant of neuron. Neurons are always in need of a assistant or a helper, like a manager or a executive officer always will have some steno for doing the mundane task. Like that, glia is always a helper cell for the neurons, and in our brain it is roughly around 1:3. For one neuron you will have around 3 glia will be present, and the glia present in the retina is only the Mueller glia, which is given yellow in color. And then comes the ganglion cell layer, which collates all the signal and then push into the optic nerve. Every ganglion cell will have one axon that is coming out of it. So this is the simple structure of the retina. So our approach to damage the retina is an injury model, because in order to study regeneration, first you need to injure the retina, and we use a 30-gauge needle from the back of the eye. And so advantage is that it will be a focal injury, and the same retina's uninjured part will act as a good control for your study. So retinal regeneration, if you look closely, what you see is, this is the first panel, first image is the actual retina, outer nuclear layer, inner nuclear layer, ganglion cell layer. Then if you injure, what happens? The Muller glia cell is the one which responds. Neurons cannot respond. They may be responding, but they cannot participate in proliferation because they don't have the centriole. They cannot undergo mitosis. So these Muller glia respond and they expand in number after reprogramming. So they start acquiring the characteristics of stem cell, increase in number, and now they dedifferentiate and proliferate. Then they start moving on to various layers. While this migration, they differentiate also. So in the outer nuclear layer, rods and cones will be formed. Inner nuclear layer, amacrine cells, bipolar cells, they are formed. And then the ganglion cell layer, the ganglion cells are formed. And it will restore back to normalcy. But the big question is, what are the genetic factors that is controlling Muller glia dedifferentiation, proliferation, and redifferentiation? So this is the theme of our research in general. So let us see what are the factors that is affecting the Muller glia reprogramming. So what we want is this Muller glia should become this. That is Muller glia derived progenitor cell. And they have both Yamanaka factors and Thomson factors. Probably you would have heard about it. Yamanaka is the one who got Nobel Prize because they could convert a fibroblast cell into stem cell. So basically total 6 factors are there. They used 4 factors. And 2 common in both Yamanaka used OCT4, SOX2, KLF and MYC, whereas Thomson used OCT4, SOX2 is there, but instead of KLF and MYC he used Lin28 and Nano. That is the only difference. So if you look closely, you can see there are so many pathways that is been worked out that is capable of positively influencing this reprogramming. The arrow indicates it is positively influencing. And there are also some negative influencers like delta node signaling, INSM1A, and whereas Lin28, ASL1A are the positive influencers in this reprogramming event. So then there comes a microRNA, that is LED7 microRNA, which can be called as a guardian of a neuron, which makes sure that no neuron gets into a proliferative phase or gets into any unwanted non-differentiated state. So this LED7 microRNA is the #1 deterrent in this reprogramming. So someone has to get rid of it. It is just like you want to unleash a dog. The greatest deterrent is the chain that is around its neck or chest, you tie down to a pole. So unless you get rid of that, unleash that chain, you cannot have that dog doing anything for you. So LED7 microRNA is like that leash. So the first thing a reprogramming event to happen is to get rid of LED7 microRNA. And I will tell you a little bit more about this LED7 microRNA with in the light of Lin28. Lin28 is the major inhibitor of LED7 microRNA. It is induced in the inner nuclear layer. This is the injury spot. This is the retinal cross section. This is in situ image of Lin28. So you can assume this Lin28 expressing cells will not have LED7. They are the actual one which is allowing to proliferate, whereas the rest of them entire cell have got lots of LED7 microRNA. So usually in all the images we'll take a section, a box out of it and then display. So whenever you see square, that indicates it is a section from the retina. So Lin28 has the ability to block the LED7 microRNA, and Lin28 is one of the pluripotency factors, and it is present in the Thomson factors and expressed in the embryonic stem cells and cancer cells, and Lin28 is found both in the nucleus and cytoplasm, and they are able to regulate the LED7 microRNA levels. This is how it works. Normally the LED7 is present in as independent genes and also in the introns, and they are formed as pri-LED7, and then it becomes pre-LED7, and then it's exported to the cytoplasm and becomes a mature LED7. So Lin28 is able to influence the pri to pre stage, which is in the nucleus, and also Lin28 can degrade a mature. That means it will prevent the supply line, and it can also damage the product. So this is why Lin28 becomes very important to kickstart. Although you have a lot of other molecules which are friendly for regeneration, the presence of LED7 will prevent their translation, because microRNAs are always anti-translation. That means the protein will not come from those many mRNAs. So this is some of them. So you can see in this qPCR, you can see all the Thomson factors and Yamanaka factors, they are expressed. You can see lin28, SOX2, Nano, KLF, OC4, CMYC. And ASCL1 is one of the proneural genes, that is not a pluripotency factors, but they are all induced soon after injury. This is 15-hour post-injury, 2-day, 4-day, 6-day and 8-day post-injury. By 8-day their levels come down. So this picture shows how lead-7 microRNA, increase in concentration of lead-7 microRNA is capable of negatively regulating the translatability of various mRNA, including ASCL1, HSPD, which is one of the regeneration associated genes. You can see with some exception of KLF4 and OCT4, these last two are controls, mCherry and actin are controls. Almost all of them, it can prevent the translatability. So lin28 is a major molecule to get rid of the lead-7, which is necessary for all these induced genes to have any meaning. So then what we did is we created a transgenic line, two transgenic line. One is GFAP, glial fibrillary acidic protein, which is a housekeeping protein of the Muller glial cell, which is expressing the GFP, so that you can isolate the Muller glial cells, so fax sort them. So as you see in this window is the cells which are collected, so that means you are having only the Muller glia. Then comes this to another transgenic line, that is a truncated tubulin promoter, TUBA1 GFP, which do not express any GFP in a normal retina. But after injury, what happens? The same line, TUBA GFP, start expressing GFP, and which can also be sorted. So if you give around 12 pops to the eye of zebrafish, you will get around 2 to 3% of the cells which is responding. Roughly around 40% of the total retinal cells are Muller glial cells. So here you get almost 40% of the total cell, because this is a native, all Muller glia are labeled. Here only the responding Muller glia are labeled. So we did some microarray analysis, etc. Why I am showing it here, I was little curious. When all these pluripotency factors are expressed, do they participate in embryogenesis? But because it is from an adult. So what I did, I isolated these cells and took and delivered into the morula stage of zebrafish and then followed it up. Up to 4 days we can see these retina-derived Muller glia cells, they can participate in various tissue formation. Because this was a wild type embryo, so I am personally convinced, because whenever you try to publish a paper, the reviewers always say, don't use the word stem cell, use the word stem cell like or having characteristics, because nobody likes to use the word stem cell. So to get myself convinced, does it participate in embryogenesis, I did this. This is not published, just I did for curiosity, and I am personally convinced these retinal stem cells can participate in embryogenesis. Okay, now I'll move on to the other section, where is histone deacetylases, because HDACs are those molecules that is helpful in deacetylation of various protein, especially the histone. That is why they have got the name histone deacetylases. So if an acetyl group on the histone, if you remove it, what happens? The chromatin becomes very compact. And if there is acetylation groups are added onto the histone, the chromatin will become loose. Hence those DNA is available for transcription. You can get the gene expression even. So we looked for the HDACs expression. What we found that it is selectively excluded from the proliferating cell. But HDAC is present in the neighboring cells. So you can see here PCNA, BRDU, which is a marker of proliferating cell. PCNA stands for proliferating cell nuclear antigen, and you can also see HDAC immunostain when you do. The proliferating cell, BRD positive cells, do not have HDAC expression. So what we felt was HDAC is an unwanted molecule in the proliferating cell. Then we thought, if you block HDAC, will you get more proliferation? A logical way of thinking. But on the other hand, we found regeneration doesn't happen at all. So we tried different ways of blocking HDAC. One way is to gene knockdown. So you take a zebrafish, anesthetize it, and then deliver the gene antisense oligos into the vitreous, and then give an electroporation, and they get into the retinal layer. So this is our generic approach of knocking down a gene. And what we found, if you knock down HDACs, why we did this experiment, we thought regeneration can be accelerated. But what we found, the regeneration, the proliferation is decreased, significantly decreased. And we were very disappointed. Oh, HDAC inhibition doesn't help. All the HDAC goes missing from the proliferating cells. So then we looked what happened, does HDAC have got any role onto the lin28? What we did was, we looked whether, we used two drugs, that is trichostatin A and valproic acid, which is a HDAC inhibitor. what we found was in injured retina, the LIN28 level usually goes up, which I already showed you. But if you block the HDAC, the LIN28 levels is decreasing because the HDAC inhibition do not allow LIN28 to come up. And as you can see here, in both in qPCR and also in the gel PCR, and this is also verified in the RNA in situ hybridization. In the control you have this much and then it decreases and you have reduced proliferation, LIN28 is not there. So now we know LIN28 is not there, then LET7 is there and proliferation is not possible. So concomitantly we saw both with the valproic acid and TSA treatment, the LET7 microRNA levels are going up. This tells why there is no regeneration. And the interesting part is not that normally in planaria and various other animals, if you make a cut and if you don't allow regeneration to happen, you somehow allow the wound to heal, then regeneration will not happen. So there is something called wound signaling is necessary. That means the body need to know there is a wound. Somehow you sealed the wound, then regeneration is not possible. If you want, even in an animal like planaria which can regenerate, you have to make a fresh cut and then induce a wound signaling, then only regeneration will happen. But we thought, is it happening in zebrafish? What we did was, we blocked up to 4 days in VPA, no regeneration happened, and then they withdrew it. Because if you withdraw it, does the wound signaling is still there? Does the regeneration happen? To our surprise, we saw the regeneration kick starts. By 8th day, when you collect it, there is a robust proliferation without giving any fresh injury. So we felt the blocking of HDAC is reversible, not irreversible. So this initiated a project, as you can see, which we followed both in zebrafish and axolotl. The question we asked was, if you block HDACs using pharmacological reagents such as TSA or valproic acid, will it bounce back or will regeneration happen? Will regeneration won't initiate at all? Remember, all this the experiment we did post-injury. But in the subsequent project, what we are talking about is a normal fish. Normal fish, you take it, no injury, just treat them with, block their HDAC. So that is what you can see here. So before going into that, I will just quickly show you that the stages of zebrafish and axolotl limb regeneration. Zebrafish fin, it's like this, you make a cut here, it look like this and it will form a blastoma and then regeneration happens normally. Same with an axolotl limb, you take a cut here and you can cut anywhere, you can cut here, you can cut here, you can cut here. You cannot cut here, you need to have at least the shoulder level in the case of axolotl. If you cut from here, no regeneration happens. And another interesting thing is, if you cut here also it takes 50 days, here also it takes 50 days, here also it takes 50 days. It's almost like telling, you make a first 1-storied building also it takes 50 days, 10-storied building also takes 50 days. That is something surprise for axolotl, but the regeneration happens. And one would dream, why it doesn't happen in humans? So what we did was pre-amputation exposure to TSA. That means we are blocking the HDACs. It impairs the fin regeneration. What we did was -3 days. To 0 day. 0 day is the amputation. That means if I am planning to amputate on Wednesday, okay, Sunday, Monday and Tuesday, it is in TSA. And Wednesday I am amputating. And then you allow them to stay. Then you allow them to stay in the normal water and you end up getting a reduced regeneration. That means you did nothing after 0 DPA, they are in water. But the regeneration blastoma is very slow and very weak, which was quite surprising to us, because you remember in retina, when you withdraw it, we are able to get regeneration, although it was post-injury, not pre-injury, and there is a meaning for this pre-injury. Same thing we did with axolotl tail and axolotl limb. So what we saw, if you pre-treat them with a TSA, you get a stunted blastoma, and you don't get a proper, ideally it should have been like this much, and you get a lump of cells you are getting. So then what we did, we followed a different time course up to 56 days. First lane is DMSO and the second one is TSA. What you can see here is they are all treated -3 to 0 day. Okay, and then you allowed them 0 day, 8 day, 12 day, 16 day, 20 days. So this is the ideal regeneration regime. Whereas TSA2 concentration, lower concentration and higher concentration, you can see regeneration is happening but at a slower pace. If you look here the digits are being formed by 24 day in the control, topmost panel, whereas here nothing is happening, and after 1 week digits are forming in a lower concentration. After almost 2 weeks, 32 dpa, you start getting the limb formation. So what we know, regeneration is not blocked and it is reduced. But I want to tell you, after injury, if you put both axolotl and zebrafish in TSA, no regeneration happens, which is useless to us. If I put it in TSA and no limb is forming, you are not able to study anything because you get no blastema. That is why we wanted to know that why it is happening like this. So TSA pre-treatment, that is, enhances the acetylation and collagen 4 levels from this Western. What we found, we just out of a hunch, we looked, let us see the collagen. So we looked for this collagen 4 levels, which is one of the ECM, extracellular matrix protein, and the blocking of HDAX will automatically increase the H3K27 acetylation level, because this acetylation, H3K27 acetylation level is cut down by HDAX, and you block HDAX, their levels are going up. That is an indication, that is basically a positive control for us to know that yes, my drug is doing its job. And along with that, we looked axolotl tail, the same thing is seen, and the axolotl limb, the same thing is seen. So we are convinced, no matter what species or what tissue you are taking, if you block using trichostatin A, HDAX will be inhibited and you end up getting enhanced levels of collagen 4. I told you already that acetylation levels, if it is high, gene expression increases. Not randomly all, the ECM proteins such as collagen levels are increasing. So this has been confirmed with the immunostaining also. In zebrafish caudal fin, you can see the collagen 4 levels are very high, and also because of TSA treatment, this is collagen immunostain, collagen 4. Here also you can see collagen 4. This is green, this is red, and again this is green. These are all high levels of collagen. Now we thought, if collagen is the villain, collagen is the culprit, if you get rid of collagen, can we restore the regeneration by treating them with the collagenase enzyme? And to our surprise, what we found, if you block the collagen using the collagenase enzyme, you are able to rescue. So there is some issue has happened. So it is increasing concentration of collagenase D enzyme, 3 concentration. This is control, and this is TSA lower concentration, TSA higher concentration. You can see here the stunted blastema, as you get it here, it is came back to normalcy, as you can see here in both this concentration. That means same thing happens with the fin and also with the limb. So we are convinced the collagen is, or the excessive collagen deposit is doing something. What it is doing, we don't know. So, but if you get rid of this excess collagen, it is friendly for the regeneration to happen. Then we performed an RNA-seq analysis of these tissue samples, and we looked what happens to the various genes. Is it because collagen was basically a smoking gun, we just wanted to pursue further. We found that because of this TSA treatment compared to the DMSO treated control, we found an elevated levels of gene set enrichment analysis. We found extracellular matrix genes are going up, and as you can see here, and the downregulated levels are very low of the 16,000 genes we looked for. And if you look at the heat map, what we are finding, this is only for collagen and this is for MMP. There is a reason why collagen and MMP have the ability, matrix metalloproteases have the ability to chop off this collagen. So what we found, the collagen levels are going up and majority of the important MMP's levels are going down because of this TSA treatment. So we should understand, just because HDAC levels are inhibited, the histone becomes loose or chromatin becomes loose, gene expression happens. Gene expression doesn't happen for all the genes. We already saw about the LIN28 in the retina. So we saw the ECM proteins are going up and their degrading molecules such as MMPs are going down. That explains why there is a deposit of collagen. And then we further went into a gene ontology analysis. What we found, there is a interesting observation we found. Lot of immune specific genes, immune related genes, they are down regulated. So we thought this TSA treatment is doing something to do with the immune cells or immune cell derived. You know, whenever you have an injury, there will be reddening. Even if you have a mosquito bite, you know, there will be a swelling, reddening. Even if you have a pimple, you see there is a reddening. That is because of your immune cells are migrating and they are creating a pro-inflammatory environment. So for any wound healing to happen, immune cells are a must. If you don't have immune cells, that is why dead body, you create a wound, it will not heal because there is no immune cell migration there. So that is what we found. Immune cells are all downregulated because of this excessive collagen deposit. So when we looked for the box plot analysis, what we found that the anti-inflammatory, that means the inflammation can be of two types. One is pro-inflammatory, that creates inflammation, then anti-inflammatory, that reduces inflammation. In diabetes, what happens is your injury, wound is always pro-inflammatory, which is mainly done by the M1 macrophages. Actually, for any injury, your body will sense there is an injury if there is a pro-inflammation. And then you don't want that pro-inflammation to stay forever. It should become anti. It's almost like you went for food to a restaurant and you don't want to sit there like a permanent member. After 1 hour or 2 hours, they will tell you go out. So, although you have to go for filling your stomach, on the other hand, if you continue to eat, your stomach will explode. Same way, pro-inflammatory is needed, but the anti-inflammatory phase has to come into picture. So we looked, the anti-inflammatory levels are going down because of the TSA treatment. On the other hand, the pro-inflammatory levels are staying high in the TSA treatment. So we felt this treatment of TSA is not allowing the dynamism of the immune cell migration. So this one, I think this regulatory T cell dynamics, this year's Nobel Prize for Physiology and Medicine has went to the discoverers of this regulatory T cells, and because they are very important, even the mutant zebrafish which has a regulatory T cells are not there, you don't get regeneration. So we looked in caudal fin, this FOXP3 is a marker of the regulatory T cell. We try to isolate the TSA treated, and this is done in the caudal fin of zebrafish, TSA treated, and the DMSA control. We found a decline in 3 hours post amputation of the zebrafish fin. We saw a decline in the regulatory T cells, and we also looked at, can this inflammatory response, that is, there is a elevated pro-inflammatory and decreased anti-inflammatory levels, can be simulated by bacterial lipopolysaccharide treatment. That means no TSA treatment, we are just introducing them to some bacterial lipopolysaccharide. And what we found, first of all, the collagen deposit was there. That means now we are convinced, instead of TSA or trichostatin A causing a collagen deposit, it is the inflammatory response, because in this case the collagen has to deposit, has nothing to do with HDAC. It is something to do with the immune cells, because we saw an increased collagen for deposit. And this is also big, when LPS is treated, you also will have a free radical formation. So we also used a free radical scavenger such as N-acetylcysteine. So you can see here NAC, with the NAC and without NAC. So we saw with the NAC the deposit is not there as much as you would expect. Without NAC there is collagen deposit, and this NAC can rescue and restore the Treg level. Like I told you earlier, the reduced Treg levels will be restored back if you put N-acetylcysteine, which can be a free radical scavenger. So what we know, bacterial lipopolysaccharide creates too much of free radicals in the site, and which creates the immune cells response, which is the main cause of this collagen response, pro-inflammatory cytokine. But if you allow the free radical not to be there with the NAC treatment, immune response is not there, collagen levels are normal, and the Tregs levels bounce back. So the proposed mechanism, what we are showing from here, is because of trichostatin treatment, what you see, the ECM levels and pro-inflammatory cytokines go up, and this happens both in zebrafish fin and also in the axolotl limb, this model, and also you can see the anti-inflammatory cytokine, which is a must, which is mainly done by the M2 macrophages, should come down. Then only you will get the regeneration. Pro is also needed, anti also needed, but pro is needed in the beginning and anti is needed in the subsequent stages. So this is the last slide of my presentation, and I will just to show one slide, because I talked about the immune cell. We also looked for one of another reagent, that is FTY720, which prevents the release of the T lymphocytes into the bloodstream. This is done in mice. So we looked into cutting the finger, and the P1, P2, P3, 3 digits we have. If you cut here with the nail bed, it will grow no matter what. But if you cut here and here, it will not grow, usually in the mice. So, but when you prevent these T lymphocytes, because this project is done just to convince ourselves that is the immune cells are the villain against the stem cell. So if you prevent the FTY, use the drug FTY720 and prevent the immune cell migration, we saw this pluripotency factor level goes up because of FTY720 treatment. This is mice, not zebrafish or axolotl. So we saw OCT4, SOX2 and LIN28 levels are going up, and we could see a better blastoma and better regeneration in the fin. All we did was we just treated them with FTY 720. So that was something interesting, something is going on, and we are also in the process of getting one model from University of Kentucky, that is the one and only model known, mammalian model known, that is Acomis mice, which is also known as spiny mice. So our paperworks are all going on. Once we have it, we are very much interested to follow it up. How come some mammals can regenerate? Is it through the immune cells? Okay, so now this is our system. The top one is a zebrafish system of Iser Mohali, and the bottom one is in the animal house, that is our axolotl system. Any of you are interested are most welcome to visit us. And this is our one old lab picture. These are our lab members without, and also various funding agencies without which no work is possible. And our lab is pretty big, and these are another few more lab members. And I will take any questions if you have. Thank you.
Sir, I have a question.
Yes.
So when the limb development is there are few pathways which are, like we say, auto activation pathways are there.
Yes.
So similar process is going in retina, in regeneration in fins also.
Yes.
And so collagenase which is there.
Yes.
So collagenase is basically, if we give collagenase, we can develop arthritis model with this. We can, because if you give, the matrix, when it depletes, you end up getting this arthritis symptoms, and arthritis also is connected with the inflammation also. So
is
that
there,
is, it could be a reason that collagenase, if there is
Yes.
a old collagen is there, that
Yes.
is going to lead to arthritis also.
Yes. You can try. It may one has to, because different arthritis model may have different manifestation. Why I am saying is, although the TSA treatment is anti-regenerative in zebrafish, it is pro-regenerative in mice.
Okay.
So there are published paper. So because it helps. So if you overexpress ASL1 and give TSA, so it is published, I think, from Tom Ray's group. They published in Science some 3 or 4 years ago. But it doesn't happen in both in axolotl and zebrafish. So we have a theory. I don't know if it's true or not. Maybe in mice the collagen levels are extremely low. So this TSA treatment is allowing some collagen deposit which is necessary. Whereas in zebrafish the collagen level is adequate. By putting TSA, that level is going up. It is like someone who is studying properly, you give him tuition, he will do badly. Something like that.
Yes.
So someone who never opened the book, you give them tuition, they may become better. So this is what we are thinking. Maybe there is a variation in the collagen level. Mice doesn't study at all. You put TSA, then the collagen comes up, it helps. Whereas in fish and exo, the collagen forms adequately, because too much collagen prevents the immune cell migration. I did not go into the details of that, because it acts like a barrier. That is why when you give collagenase, it opens up. So first pro, and then the pro immune cytokines has to be withdrawn by the adaptive immune cells. First is the innate immune cells, get into the place, creates a pro-inflammatory environment, then they will be moved away. Some of them will switch also. M1 to M2 macrophage switching also happens. M1 is pro-inflammatory, M2 is anti-inflammatory. But this moving in and moving out, collagen will act like a barrier because it is extracellular matrix. So, but adequate thing is needed also. That is why I did not emphasize on it. In normal zebrafish, no TSA treatment, you just give collagen, regeneration is affected.
Yes.
That means collagen is not a villain. Collagen is needed. But too much collagen is the villain. So that is why too much you prevent it, you get regeneration.
So just for general public also, if we ask, like all the creams which we are using, mostly it's a collagen.
Yes.
So it's a good idea of using collagenous creams.
So normally what happens, our tissues, so they can have lots of depletion of collagen. As you, especially though in old days, some people get, because in old days our body will have lots of pro-inflammation for no reason. Lots of pro-inflammatory free radicals, etc. As you grow old, like compared to 10 years ago, now you have more pro-inflammatory environment. So this can, some individuals, it can create a over production of collagen. For them it may not be helpful, but if you are some part of your body is exposed to damage, cell damage, then there you apply this collagen, it will act like a barrier and a helping protection. So it can, ECMs are basically protection, but for some people, if they have inflammation already set in their body, that is creating a collagen. That is why some people get, fibroids, etc. They get it. That is nothing but collagen. That in the old days, some people get in their face, people call wart or something. For no reason, they will get some growth. That is a fibroid. That is nothing but collagen, excessive deposit. Sometimes they will be cell-free also. That is because of their pro-inflammatory internal milieu. Sometimes it will lead to cancer development also. So your inflammation level should be low. So that's why one should take a food such as curcumin containing turmeric and or vitamins. Many B vitamins are anti-inflammatory. So reducing your inflammation helps keeping the skin health, etc.
Thank you.
Yeah. Any other questions? Thanks a lot.
Thank you, Dr. Ramachandran, for accepting our invitation in such a short notice. You beautifully unfolded how hashtags regulate immune cell dynamics and ECM remodeling during appendage regeneration in zebrafish and axolotl.
Thank you.
Thank you so much, sir.
Thank you.
Now I request and invite Dr. Karuna Shri Paudila, additional professor from AIMS Kalyani, to felicitate Dr. Ramachandran, and also request other dignitaries, Dr. Ravi, Dr. Damanpreet, Dr. Banappa, to please join.
सर यस प्लीज सर मैम वेट करना चाहिए सब थोड़ा सा क्लोज है यस प्लीज यस लुक हियर थैंक यू सो मच
Department of Pharmacology, ICMR, National Institute of Traditional Medicine, Belagavi. And Dr. Banappa holds a PhD and M.Pharm in Pharmacology from the Rajiv. Over 2 decades of research and training experience, he has mentored several scholars and more than 49 postgraduate students. He spans drug discovery, development, and drug discovery domains. He has undergone advanced training in radioreceptor assay, gene silencing, siRNA techniques, DHR fellowship on genetic toxicology, metabolomics, and principles and practices of clinical research. And as principal investigator, Dr. Banappa has led several major research projects, including phytopharmaceuticals for rheumatoid arthritis, AAA for sustained weight loss, bioprosection of tribal medicinal plants for arthritis, and AIDS and TB project, which is a multicentric implementation study. So he has successfully executed projects exceeding 4-5 crore in funding, several of which hold direct policy and clinical relevance. His work integrates traditional knowledge with modern pharmacology, emphasizing transitional translation and implementation research through national and multicentric collaboration. And he will be delivering a talk on metabolic disorder, a research area very close to my interest, and he is using zebrafish for the metabolic disorder. So over to you, sir.
Thank you, madam. Thank you for the kind introduction. At the outset, I would like to thank this IPS and also this organizing team for inviting me, giving this opportunity to interact with you people. So, to begin with, this presentation is a compilation of that other studies also and our own work also. So coming to this, the introduction, this metabolic disorders. What are the metabolic disorders? It is a cluster of conditions actually. It includes the obesity, diabetes, hyperglycemia, non-alcoholic fatty liver syndrome, dyslipidemia, and so on actually. So it's a group of disorders, and to model that group of disorder in a model is a very challenging task also, but it has a high impact also, because these metabolic disorders are emerging like an epidemic. And it's not only, earlier we thought it is occurring only in the developed countries, but now the India is becoming the capital of this diabetes, obesity, and in near future we will be having a huge challenge of these non-communicable diseases associated with obesity and metabolic syndrome actually. So it has a huge health burden on exchequer. So focusing on this area and developing the model, it is a high rewarding area also. So, and these animal models are integral part. Having said that, now we are using several other models, non-animal models also, but we cannot dispense completely an animal testing. So we need suitable animal models to study and develop these drugs or therapeutics and also diagnostics. So zebrafish in recent days has emerged as a versatile vertebrate model, although it is not mammalian, but it has got a lot of similarity, and it has emerged as one of the important model for studying these metabolic disorders. I think it's not working now. So, having said that NCDs are important, animal models are essential for the science, there are already well-established model, rodent models, which is a mammalian model and has a high translation value, lot of acceptability across this scientific domain. So, now I was also trained long back, 25 years back, in research using these rodent models actually. I was very much comfortable and expert also, I can say. At that level, as a student, as a PhDs, we did a lot of work and we were very much happy with that, the tools and technologies and our skill which we had. But what made me to think to go for these alternatives long back in 2012, and as shared by previous speakers, I didn't know that what is zebrafish, where it is available, and I also searched everywhere, went to these pet shops also, and went to the river streams also to collect on my own. It was a wonderful journey, I can say, very satisfying also. But it impacted me in my publications, scores and other things, because to start with that, it was a very challenging job. We failed several times. Fortunately, in 2015, I got a small fund to get one aquarium and establish my lab in 2015. But again, it didn't take up early because it's not my cup of tea. I didn't know that what is the skills required for these, modeling these species actually. Passion made me to stay in that area, I say, that no, we fail and it will actually impact our the performance scores also, so-called H index and other things. But definitely, having the outcome is very important. Particularly that nowadays, output is not important, your publications are not important, your H index is not important. What ultimately it has translated, whether now the ICMR is particularly focusing on what is your contributions to the policy, what is your contribution, whether your studies are taken into practice or any treatment guidelines, are there any products developed. So it is not easy, but it is expected from us, as an ICMR scientist, preclinical pharmacologist, I face a lot of challenges. Why I am telling this story is that you are all are maybe beginners, may have already explored little bit. You compared to the 10 years back, now the literacy rate or the awareness and availability of the resources, hand-holding institutions are also there. So it is relatively okay compared to the earlier days, but definitely you will also face the challenges. As my friend shared, sourcing these zebrafish, still there is an issue. And as he thought, similar way I also started building that big facility so that we can breed and provide those animals to the neighboring institutions who want to use. We are still, recently we got that good facility, we are still in the process of breeding. As per the rule, we have to get an approval for selling, that is in process. So coming back to that scientific reasons why the zebrafish is a good model. First of all, it is a vertebrate and it has a many similarity with the humans, because our research is focused, our end goal is a human health. So the model or the biological system which we use should have the similarity, then only there will be a translational impact. So for that reason, it is a very good model because it has many similarities in terms of genetical makeup. It's already been shared by my colleagues earlier, that I don't go into the details of it, but I will focus mainly on with respect to the metabolic syndrome or metabolic disorders. So you see that all the organs which are important in the metabolism is the liver, pancreas, adipose tissue, skeletal muscles, and also kidney. Very surprisingly, many people will not understand this. Kidney is the place where this insulin gets degraded. So that insulin degrading enzyme inhibition is one of my objective, but we could not produce sufficient data and we have very few publications on that. So what I mean to say is it has got various organs which are similar to that of humans, both physiologically functioning in the similar manner, and the disease with the pathology also similar. So and it responds to the drugs, pharmacological agents in the similar way. And the toxicities which are produced are also, the toxic to the human, toxic to the mice is also toxic to this. So that, and in the similar way, the pharmacological actions are similar. So it makes us a lucrative or an attractive model for adopting to study our, to meet our objectives of the research. So some other reasons, it is very small in size, so we can maintain it in the small space, and it has a high fecundity, so that you can get the many number of animals. It is not seasonal also. You can get whenever you want a sufficient number of animals for the research. And it is a rapid development also, that the time required to complete your study will be less. Like that, and it has also got a transparent body at the early stages of the life. That is one more important the feature which makes us this model as a very good model for pharmacological studies. And most importantly, it was the ethics. And that is why I adopted this, in fact. Surprisingly, I had a dilemma, whether science or the ethics. To get on publications, you have to do the research, you have to sacrifice a lot of animals, and it has not getting translated. Of course, everything will not get translated in the short span of time, but still the expectations and the outcomes, I was not satisfied with that. So if we are doing, at that time I was in academics as a associate professor in the university, so I thought that now for teaching and training, it is better to use some alternate model organisms, and we have used it. So it is a 3R compliant. That is the one of the important aspect, as my colleague said, that now lower sentient animals comes under one of the R actually. So we have to adopt this. And it's cost effective also. So the most important is the metabolic pathways and its relevance to the disease of our interest, where we want to study, develop drugs. This organism possesses all these endocrine cell types, alpha, pancreatic alpha cells and beta cells of pancreas. They produce insulin, glucagon, and it actually mirrors the human pancreatic function. That is our target organ. No? So for the diabetes and metabolic syndrome. Like that, another important organ is the brain, where this hypothalamic circulatory, now which regulates this energy expenditure or energy balance in vertebrate, is also conserved in this animal, similar to that of the rodents and the humans. Okay? So as in humans, this zebrafish will also produce a leptin receptors and receptor proteins of this melanocortin system, okay, which are expressed in this hypothalamus. That is also an added advantage, that it has got a complete system. So overall this is affecting on the whole body, so the translation value will be very high. And there are established models by various methods to induce obesity, hyperlipidemia, type 1 diabetes, type 2 diabetes, and hyperglycemia also. There are simple models also. So you can see here the techniques to model the metabolic disorders in zebrafish. There are various ways. You can put a diet which is containing a high fat, or you can feed the normal diet, that is Artemia, in excess quantity. So that produces the obesity. Okay? So diet induced models are also there. Chemical induced models also, like the routine naloxone or these streptozotocin which we use in rodent, can be used in this model to induce the diabetes. And a very simple method is just immersion in the glucose solution, induces the hyperglycemia. So that is also accepted model. So there are genetic tools also, like CRISPR-Cas technology can be used to target the specific gene silencing or a gene knockdown kind of a thing. So what are the characteristics, characterization of this model, and what should be the readouts? That relevant readouts should be there. So how do you assess that your model is appropriate? So here you can assess the body fat, that's in a human also, the obesity, there is an accumulation of fat, particularly in the visceral fat, abdominal fat. So that is most relevant also for the human studies. So that same thing happens in this model also, if you feed them with an high fat diet or the excess Artemia feeding. Instead of feeding the 5 mg per day per fish, if you provide them a 60 mg of the Artemia per fish per day, it happily consumes, and within 8 weeks it becomes obese, having all the characteristics of the human pathophysiology. So that's one of the simplest model which we have used also. And we have also developed a model using this the drug-induced obesity also. One of our publications in early my career in 2006, it's a olanzapine-induced metabolic abnormalities in the rat, which we have published in European Journal of Pharmacology. So olanzapine, a typical antipsychotic, is a very good drug actually. It reduces all these psychiatric symptoms, but it has got an adverse effect which disturbs the metabolic function, and there will be a metabolic syndrome in those patients. ये क्या होता है, एक symptoms कम हो गया, but another complication which is more concerning actually is happening in those patients. So we thought that whether does it happen in the rodent. So we found it is happening, but it is a dose dependent, sex dependent, lot of variability was observed, but we published all those the changes which happen and what is the appropriate dose under the sex, even in the age also. Maybe it is an hormonal interactions at different age which is interfering. So the similar olanzapine, whether it causes these similar symptoms, metabolic abnormalities in zebrafish or not, which we did an experiment and found a very good encouraging data that it causes a metabolic abnormality, mainly it disturbs the metabolic rate. So that also we published in good journal actually, Future Journal of Pharmacology. And another the thing which you can read out is the visual tracking of organ development at the different time points, and also the fluorescent labeling for the real-time metabolic dynamics also you can. It has got a huge translational relevance. This has enabled identification of several anti-diabetic drugs. A lot of reviews are there, a lot of publications are there nowadays. You can go through that, and insight gained in a mechanism of this metabolic syndrome is also very helpful for the translational impact in terms of this obesity and diabetes. And visualizing this beta cell regeneration and complication of diabetes. This we have taken up now and yet to perform the study, that now homeopathic drug which we say this the streptozotocin which we use in routine pharmacology to induce the diabetes is being used as a anti-diabetic in homeopathy. So what is the mechanism, how it can cause that regeneration kind of a thing, which are some evidences say that no suboptimal dose of streptozotocin actually causes the regeneration of beta cells instead of ablation. So in our own experience also, when we were students, M.Pharma and PhD that time, when we were inducing streptozotocin, when we prepare streptozotocin solution in the citrate buffer, the first animal gets high glucose level, and as the time lapses, because we are not experienced in that, so we took a lot of time, and with the time that streptozotocin gets degraded and suboptimal dose of that streptozotocin induces possibly, but that time we were getting confused. Streptozotocin तो induce करता है, ये तो हमारा इसमें हो ही नहीं रहे, पहला 2 animals में हुआ है, दूसरा में नहीं हुआ है. We were unable to interpret what is happening that time. But later on, when some literature indicated that suboptimal dose of this streptozotocin causes actually initiates the regeneration of beta cells. So that's an hypothesis again. We are testing that hypothesis. So this was the paper which I mentioned, using this Artemia, simple food, natural food. Instead of 5 mg in the control, that is the normal, and if you provide a 60 mg per day per fish, so it will induce the obesity kind of and form these metabolic abnormalities. This is our paper, olanzapine induced metabolic abnormalities. There is another paper which we got published in the recent in 2025 itself, and recent issue actually in a chemistry select. So it is one of the traditional medicine being used in Ayurveda for various purposes, and we got a hint that it can modulate this metabolic rate and hyperlipidemia can be controlled. So what we did is we induced obesity or metabolic abnormalities. We measured mainly the lipid accumulation and the metabolic rate. Those are the underlying pathological sequences which actually leads to the accumulation of fat and the increase in the body weight. So to understand that whether these extracts and their fractions, we have identified a few compounds also in that whether they are going to alter this metabolic rate or not, and we found an interesting result actually, and we got published. This is the paper, the graphical representation of our paper. So what we did is we did an in silico studies also, network pharmacology also, and we have identified the multi-targeting effect, and we have identified some compounds and enriched, the fractionated them and confirmed with the LCMS, and when then we treated to the fish which are fed with the IFAT diet. Okay. Egg yolk solution was fed to this zebrafish larva, and then it was treated with these extract fractions also, and we have measured that how much the lipid getting accumulated or it is spent. Okay. And with the help of this metabolic rate assay, using very simple assay again, and resozurin is a non-fluorescent dye, but it gets converted into resofurin. I mean, it gets reduced when there is a metabolic rate, or with the help of NADH2 it gets converted into resorufin, which is fluorescent, and it can be used as a marker for the metabolic rate. It is a well established the method also for assessing the metabolic rate. So we have adopted that, and we have found that it has got some interesting results, and we are identifying those bioactives. So another paper is on Euphorbia hirta. It is again a traditional medicine used in various systems including Ayurveda, but its effect at molecular level or at the physiological level is not known, and we subjected again in the same model, high fat diet fed obesity, or you can say metabolic abnormality. So we have assessed its effect on the metabolic rate and fat accumulation, and found a very interesting findings again. Again, these are further under progress. So this is one small study by our PG students. They come as an interns and they do some of the studies. So here what we developed that olanzapine induced obesity model, that metabolic abnormality model. In the same model we have used the extract of Egel marmalus and assessed its effect on the metabolic rate and the fat accumulation. This is another study on Terminalia cebula, which is again a part, now it is a component of Triphala. It has a very good, already several reports are there. It is a very good hypolipidemic agent, and we have found whether it has got any influence on metabolic rate. So Garcinia indica is the another drug, another medicinal plant which we have taken. Here you can see there is no, both in the adult and also the larva you can do the metabolic rate assay. That is a technical, very interesting for you people, I assume, because how to do that metabolic rate assay? It can be done in the microplates, putting these larvas also, feeding them with this high fat diet or the egg yolk solution. You can feed them and induce that metabolic abnormalities and treat the substance of your interest. Then you can assess the metabolic rate, taking out just an 80 microliter of that sample and put it in the microplates again for the fluorescence reading. So in the similar way for the adults, how to do it? That's the question. And these are all not new, it's already published, as I mentioned in my disclaimer. These are all the published methodologies, where now in the 50 ml the conical flask, a centrifuge tube, you can put 50 ml of this resozurin solution of 0.02% resozurin concentration is found optimal for assessing. It is a safe also. Higher concentrations were found to be toxic, but at the 0.2% it is safe to assess the metabolic rate. So put the, you can put 1 to 3 animals in 50 ml tube, and at the different time points also, from up to 3 days you can study the effect of drugs on the metabolic rate. So this is a type 1 model that using an multiple dose of streptozotocin. Here 350 mg per kg streptozotocin intraperitoneally will be injected to these zebrafish. This is a study which we are taking up now. We have not completed it. So here streptozotocin will be given in a first week 3 times, alternate day. Okay, and after that for the 3 weeks a booster dose of streptozotocin should be given, so that now you will be having a type 1 kind of a diabetes. So the parameters, outcome parameters will be again the similar, the fasting blood glucose, lipid profile, and some inflammatory parameters that is of our interest actually, that now the interventions may act through these inflammations, so we wanted to assess that. And also the morphology of islets, pancreatic islets and liver glycogen content we are estimating. In addition to that, molecular markers, particularly the PDX1, because it is one which is overexpressed when the regeneration of beta cells takes place. So the strengths and limitations of this model is, it is a rapid assay, you can do it very quickly, and live imaging can be done. I have some videos, I will show that how the live imaging will look, and already the previous speakers have shown some of the videos. So it is an high throughput also. Now in a 96 well plate you can put so many, very quickly you can assess the drug for their effect. And it has got a conserved metabolic pathways, so that is one more strength of it. The limitation is there are some differences. For earlier in the inauguration also our speaker, chairman told that for everything there is a limitations. We have to understand that limitations and we have to club wherever it is feasible all these suitable models to arrive at our conclusion. So the main difference here is a lack of brown adipose tissue. When we speak about that metabolic syndrome, madam, actually the brown adipose tissue is very important. Non-shivering thermogenesis, it cannot be produced in this. That's the major problem. So my goal was identifying these bioactives which are browning or beezing agents, what we call, converting these white adipose tissue into the brown adipose tissue. That is the goal actually, that but it is not possible now. It is feasible in the case of the most models. So it actually incomplete recapitulation of these human multi-organ interactions. And there are some advances also, like adopting these metabolomics approach or genomic approach to understand in a deeper way that at what all targets, what all signaling mechanisms it is getting affected, and development of the fluorescent reporter lines are also known. Many researchers have developed and it is available for the usage. We can get them and we can study if our research objectives are requiring them. So integration with the personalized medicine or a traditional medicine where it's a multi-targeting effect is found to be good approach compared to that single targeting approach. So there are a lot of unanswered questions are there that will is the future direction actually. The conclusion is it's a powerful model, no doubt. It's a versatile model also for studying metabolic disorders. Many of these questions can be answered using this model. It will also enable us to study the mechanism and to develop these drugs with a high translational possibility. So ongoing innovations will further enhance their utility in the future in the metabolic research area, I hope. So this is our facility. We started with that, as rightly said, our journey started with this small in-house facility with the help of a fisheries expert, and then we started with this small the interest of animal welfare also. Otherwise, a lot of these higher animals, I call it as higher animals. The rodents which we use, we have a rodent facility, but we rarely, we first do it in these models, and we have recently developed a C. elegans facility also. We are doing all these different tier approach, and if it is required, definitely we have to use these rodent models also. How to run this video, I don't know.
Click on it.
So, hope you are able to see this. So we are using this system again. There are some other contaminant organisms also. This was a photograph or a video of which was taken in 2015 actually, when I started this establishing this facility. So here you can clearly see the heartbeat. You can count the 15 minute, you can record the 15-second recording, and later on you count the heartbeat and then extrapolate it to the beats per minute. And we are now one of the PG student is using this heart failure model, aristolic acid induced heart failure model, which is an established model in rodent. It induces a similar heart failure conditions in this model also. We are using to screen these Ayurveda drugs to see its effect on cardiac function actually. And we wanted to see that the cardiac, circulatory system also, effect on circulatory system. And you can hope you are able to see that the peripheral one is the vein, and this is the arterial system. So there is a clear visibility of the flow of blood in the vessels. And if there are any clotting, because we want to, earlier we wanted to study effect of these, clotting disorders. So for that we tried to do it. This is one more video of this same. You can see through that now all the functions very clearly. So this is our beautiful team and a beautiful campus of ICMR, the National Institute of Traditional Medicine at Belgavi. And these are our PhD, and one is a postdoctoral fellow. These people have contributed for these different studies which I have presented here. And we have an opportunity also that for the youngsters who are free to, exploring these job opportunities or the research opportunities. We have one project on arthritis. We want to expert those who are motivated to work on immunology, biotechnology skills, with the biotechnology skills to contribute in our project. Thank you.
Any questions?
I'll be very happy to answer questions, sir. Please.
So we are also working on anti-hyperglycemic effect of few microorganisms in zebrafish. So I'd like to, there are two questions. We are giving this streptozotocin in the intermedia itself.
Okay.
And also the microorganisms that we are studying for the
okay.
effect. So also we are giving the intermedia. So I would like to know whether this is the correct route of administration of the streptozotocin as well as the microbial agent that we are using, and how the streptozotocin enters, for example, any drug enters into the zebrafish.
Actually, the streptozotocin is given intraperitoneally, and if you have references, if somebody has demonstrated that even oral exposure of streptozotocin is causing a sufficient hyperglycemia.
Yes, we have.
Then okay, I am not aware of it, sir.
I just wanted to know how it enters.
Actually, maybe through the gut, it may be directly going to this liver and pancreas and getting the the pancreatic cells getting damaged. It's very interesting actually. Otherwise, generally we are using only the IP injection methodology. And another question is very important actually. If you are studying microorganisms and microbiota, I hope you are.
Microorganisms which can cause non-specific anti-hyperglycemic effects.
Okay. So it's an infecting that organism with this microorganism. It's a live or live organisms. Actually, that needs an aseptic. At what stage you are using them, sir?
Larvae at around 4, 5, 6 DPF.
Okay. Because no, once they come into this system water, all these organisms, contamination is there. There will be non-specific effects also. So, but the larval stage is just hatching. They are sterile, you can consider, and the effect of your specific microorganisms can be attributed to the outcome. Otherwise, there will be huge other microorganisms also, it gets exposed to with the system water itself. That is the one concern. Otherwise, it is also very good approach, sir. You can infect these zebrafish through the system water also. Hope I have answered, because it's not my area there. We have not worked on that. Still, that's okay.
So it was a general question. Giving any drug into the zebrafish is just is it the right way to just put the drug into the
that's really very important question.
Do they need to inject it or give it through a particular route?
Exactly.
It was a general question.
No, sir. I really appreciate this. This is very important. Otherwise, no outcomes will be attributed to the wrongly. Whether it gets absorbed, first of all, yes. Whether the drug, particularly when we are working with extract and the fractions of this natural product, whether they are soluble, whether the concentration is uniform. That is very important. Otherwise, that gets precipitated or not at all getting absorbed. So for that, it is ideal to give it through the oral ingestion. I mean, the oral gavaging, like in a rodent we give, in the fish also we have to directly give if your route of administration is oral route. And if possible, if they are sterile and it can be injected, IP route is the best one to attribute the effect of the interventions to the outcome. Otherwise, there may be chances of false negatives also.
So may I add something? So actually, if you put it, it is very much right if you put then ambient water also.
Yeah.
And as per the OCT guidelines also, you can do that, because in case of fishes, normally the things enter through the gills.
Yes.
So that is a part, one more mode from where it can enter. So you have to make a combination and see also. You have to see the results also, preliminary results. But it is very good if you add in the ambient.
The most common route of giving
is through the system water.
Oral as well as, when the fish takes in water through the mouth, then it comes out from the gills. So that is the circulation which takes place. From the water they are going to take, along with that particular dose is also been taken, and then through gills it is going to come out.
The most frequent method is this putting in the system water.
Ambient.
That is the easiest one also. The next, but for
the most common question asked in this way is how the drug enters into the.
Yeah. So this is the how it enters.
Actually,
your question is appropriate, because being a pharmacologist is definitely how much drug is entering, Cmax, and we call it as Tmax. That all raises concern when we go for drug administration through system water. But
yes.
Definitely for larva, we don't have any other option.
Yes.
And there are certain publications where they have given drug orally to larva also. But I must say it is practically difficult when we are talking about academic research. And that's true. The correct way is when you are very much concerned about Cmax and Tmax, when you are directly going to the development of certain things, to go for some this method like IP or orally. But in fish we consider both of these methods a little bit invasive, because to give intraperitoneal injection we have to first anesthetize the fish, and using cold water or certain other things. Trichine we avoid because we are interested in pharmacology. We don't want another drug to have some interaction with that. That's why we go for cold treatment. But still we have to anesthetize the fish, we have to restrain the fish, and then we have to give the injection. There is reproducibility is another issue. So that's why concerning this, if we are considering it as an alternative model, then definitely we have to have some alternative routes also. That's why we go for administering drug through system water. But you are correct, these questions will be asked when you have to present yourself, your findings to a pharmacology person.
So few things to make sure is, sir, first whether your test compound is water soluble or not, and how much stability it has got. Okay. And if you are, and if it is not soluble, then you can use the DMS also in a permitted concentrations. And if it is unavoidable because of expertise and other conditions like no, you cannot use anesthesia and other things. Otherwise, it is better to give it orally. If it is intended route of administration is oral. If your intended route is not oral, again, because it is getting metabolized in the liver, so oral route is not an ideal one, then you have to inject. For that, you have to use this micro-injection system, sir. Even in a larva also, you can directly put into this blood circulation using this micro-injection system. We are in a stage of procuring those actually.
I have one more question adding to this. Is only the gills only the route for the dry
No,
entry?
no, sir,
or
if
from the
skin, sir said, when sir said about larva, mostly it's absorption through skin also. So that is also there, but larval stage maybe they are not even taking in much of in E3 media only when we are, I don't know at which stage you are talking, but
it's almost 7, 8, 9, 7 to 10 degrees days post fertilization.
Days post. So that means through oral also and through skin also it can happen. It can happen.
And to ensure that whether it has entered into the system or not, you can put some of these larvas for the LCMS and confirm whether it has entered into system or not. No sir, you have a compound. Okay, you feed it through oral route or injection, whatever. But to ensure that how much it has reached into the circulation in the body, we have to wash them with that our distilled water or even with the E3 media, and then triturate them or mince them and then feed it to the LCMS chromatography to determine the concentration of your test drugs. So you can be sure that what is the concentration which is there in the body, and it can attribute to the effects.
Here you can do, if it is so mandatory that you have to go for determination of drug concentration in the blood, so if it is a pure molecule, you can go for fluorescent tagging. So there you can get the exact amount.
Yes.
No, the intent was not concentration estimation, but it was a general case.
Also important question.
Sometimes supervisors or engineers, they ask.
No, it is very thought provoking also how much has entered and
how it enters, how much.
These are some of the limitations of zebrafish. How to determine how much has entered the zebrafish. So thank you, doctor.
how reliable it is, the results and all that.
Sorry, madam?
How much
Reliable. Yeah. So if you are having that data, how much concentration of your drug is there in the body, then the data will be reliable. Otherwise, we are assuming it based on that data which we have. We cannot be sure that now what is the concentration which is producing that effect. Even though you know the concentration in the media, that exact concentration, whether it is there in the body, in the circulation, we don't know. For that, only the way is to estimate that concentrations in the body.
Thank you, Dr. Ungar, for illuminating the power of zebrafish model in metabolic disorder. Your talk on integrating traditional medicine with modern zebrafish-based research beautifully highlighted the potential of holistic approaches in advancing metabolic disease studies. Now it's time to felicitate Dr. Ungar. And we have amongst us Dr. Sebastian Faure, Dean Faculty of Pharmacy, University of Angers, France, who is one of the speakers at IPSCON 2025. We welcome you, Dr. Sebastian Faure. And I also request Professor Ranju Bansal, Professor of Chemistry, UIPS Punjab University, and Professor Poonam Piplani to please join.
Yes, ma'am, look in please. Sir, you have wait. Yes, yes, please. Yes, look here. Sir, yes.
If you have any questions, please feel free to contact me. I have given that our contact details, and during lunch also, and I will be there for today and till the day after tomorrow afternoon. You can have interactions.
Now, thank you all of you. After lunch, you will be having hands-on training on zebrafish in zoology department. The QR code for the location has been given on the iCard, so you can use that to scan, and you can reach there on time. So you have to reach there by 2 p.m. Right?